Hello everyone, very good evening to all of you. How are you all? So I hope every one of you is doing absolutely fantastic. This is your chemistry expert Sanjay Arya sir, and today we will be starting this very new series in terms of chemistry. You already have covered mathematics and physics. So every Friday will be your day of chemistry, where I will be covering one of the theory sessions of complete chapter. Our today's chapter for all the 11th standard people is none other than mole concept, which is the first chapter, and the alternative name of this chapter is some basic concepts of chemistry. And believe me, I will cover every single topic coming out of this chapter, including all basics to higher advanced level concepts. So let me start with the first part. Let us introduce myself, everyone. My name is Sanjay Arya. I have completed my graduation from IIT ISM Dhanbad exactly some 15 years back, and I have been teaching in past 10 years, mentored over 5 lakh students, and I have produced some of the very fascinating double and triple digit ranks. My target is to produce even more, and I want you people to be more focused, and believe me, one day you will also be getting selected by these particular very good marks and ranks. Now we have this chapter, which is some basic concepts of chemistry, the very first chapter of 11th standard. We have some certain topics over here that we have to cover throughout this lecture, and then this theory lesson will be completed. We have brief introduction of chemistry. So those who are just studying even from 10th standard, they have come to 11th standard, they have no clue what chemistry is, what is the mole, what is mole concept. They all will be benefited by this lecture. We will cover matter and its nature. We will cover matter, its measurement, its properties, laws of chemical combination, Dalton's atomic theory. We have mole concept, molar masses, stoichiometry calculations, and then applications of the mole concept, in which one of the topic comes as concentration. So that will be the flow of this entire chapter. Take an idea of this flow of the chapter, and whenever you study, guys, my suggestion is that since you people are right now working or preparing yourself for 2026, you must carry a notebook with you. It should be a proper what should I call it, a notes should be there that must be written by you. And rather than just simply writing the formula, I would like to ask you that if you are covering this whole lecture, you must have your notebook with you. You must write everything line by line, one by one, and try to make very detailed notes. Then out of which those who are preparing for 2025, or those who want to who are having this exam in within coming months, they can do preparation of short notes. Rather than going for the detailed note, they can go for the short note. But short note also should be in a proper flow, in the same way where I am teaching, and the similar way you got to write every single formula. That is for short notes preparation, and those for those people who are preparing for 2025 or their exams are nearby. For 2026 people, you got to focus upon the basics, and then you have to cover every single part of this chapter. So do write everything in very detail, exactly like I am explaining to you. So guys, first of all, what is science? Let me just give you an idea. We have this topic called as science. And why are we studying it? Because anywhere we people have opted science as a subject, we all must know what is science. How are we gonna to lead with science? So guys, science is nothing but the study of the systematic study of nature and various natural phenomena. So that we can make the world better, we can contribute in somewhere. So guys, a very good example of this betterment can be the use of vehicles these days. So initial level uh, only like human beings used to carry other human beings in order to the rich people used to get help of the servant people in order to transportations from one place to another. And later on with the time they got animals with a like cart was attached to the animals, such as bulls or horses and camels they used to take in the advantage. Later on with the necessities and with all the upcoming improvisations, we reached to engine. Then we somehow reached to the working of an engine with using a fuel without like what should I say, unnecessarily harming the animals or human beings. Then we reached to some modern, and modern these days we are always coming to advancement. Nowadays we have flights going here from there. We also have some sort of jets which are very powerful these days, can cover the distance as well as very fast they can move. So everything is coming with the science, with the study of nature and natural phenomenon. This is what we call as the science. So number one thing that we need to know is what is science. We all know that science is nothing but the study of nature. Now we must go, what is science made up of? What are the branches of science? How many branches are there of science? We have plenty of branches, out of which a few of them are here dealing with let us suppose space science. We have space science and something study about the space objects or spatial things. Earth sciences belongs to the earth, maybe its crust, maybe its the top part, soil. So basically geology, geographical, these things may belong to earth sciences. Biology is something that belongs to living organisms. Then we have physics. Physics deals with this physical world where we can observe everything. This science is made up for the macroscopic particles which are pretty much visible to us. We can work on them, we can find where they can go, what is the scenario given, everything. At last we have chemistry, that doesn't come very easily. Chemistry is a mystery. So what is this mystery? The mystery has a definition that chemistry is a branch of physical science that studies the composition, structure, properties and changes of the matter. So more or less, if I want to write the definition of chemistry in just one line, what I can say that chemistry is nothing but the study of matter. Chemistry is nothing but the study of matter. So matter, now we have come to another definition. From one definition now we have reached to another definition. Now let us see what is the definition explaining to us. Chemistry is basically the branch of physical chemistry, physical science, that studies the compositions, like what is a substance made up of. Whether a substance is made up of atoms, we'll call it element. If a substance is made up of some molecules, we'll call it compound. If a substance is made up of formula units or counter ions, we call it ionic compound. So that is what the composition means. Then properties, its characteristics, and then we have changes. Changes means the reaction. In chemistry, whenever the term change come, we are talking about reaction, whether it's a physical reaction or it's a chemical reaction. So guys, ultimately we reach to one important part, that what is chemistry? Chemistry is nothing but the study of matter. Now the another question comes, what is a matter? What's the matter, dude? So in our daily life, we usually say this to even our friends. What's the matter, dude? Guys, that matter and our chemistry's matter are two different things. This matter means it's anything that has mass and can occupy space. So anything in this universe, in this observable universe, let's suppose this is a pen. This pen has its own mass. If you put it on the weighing machine, it will show you some deflection, it will show you some readings, and also it occupies some volume in this space. So anything that has mass and occupy volume will be considered as a matter. Take an example, everything you see around yourself, it's a part of matter. Example, pencil, pen, book, laptop, water, juice, whatever it comes, it's matter. And the matter matters. So I would like to ask you one question. In order to continue the same part, my suggestion is, like, can you give me this answer, that is shadow a matter? So guys, what is happening? I am standing right over here. Light might be falling on me, and the absence of light forms a shadow here, and no doubt it is occupying some volume. A shadow might be occupying some area, some of the area over the board. Now the question is, can we consider shadow as a matter or not? So the question is pretty simple, that is shadow a matter? And the answer will also be pretty simple, that shadow is actually the absence of light. Shadow is nothing but the absence of light plus it's massless, although it might be occupying some of the area. But the question is, since it's massless, it cannot be considered as matter. So not a matter. A shadow cannot be considered as a matter. More or less, it is nothing but the absence of light. A matter is absence of light, and shadow is absence of light and cannot be considered as a matter. Then we have some characteristics of matter, because this whole chapter and whole chemistry will belong to matter, and everything we'll be discussing in this chapter will be an outcome of the classification of matter only. So we have to cover these all part. We have characteristics of matter. So guys, a matter is actually made up of a large number of tiny small size particle, and these particles are called as the constituent particles of matter. These particles of a matter can be atoms, molecules, or ions. So particles of a matter are actually attracted by force of attraction called as interparticle force of attraction. Similarly, the particles also possess distances or differences between them in terms of space. So they are called as the interparticle spaces. Like, take this example, everyone. Like, if you want to fill this box of some spherical sized ball, whatever the maximum number of particles you're filling, you will always get some space called as interparticle space. This is your interparticle space. In the similar way, these molecules or these particles attract each other. This is called as interparticle force of attraction. Next is, these particles always remain in continuous motion. This motion could be translational, vibrational, and rotation. Let me give you an idea what is the meaning of these type of motions. So guys, whenever something travels in one linear direction, translational motion, or is also called as motion in one dimension. So like A to B, this is translational motion. Number 2 is called as vibrational motion. Now we must know what is the meaning of vibration. Vibrational motion means to and fro motion. To and fro motion means there is a mean position to which a substance goes here and there. This point might be A, this point might be A, but the distance between these 2 points is exactly the same. Let us say this is X and this is Y. So X is actually equals to Y. This type of motion, continuous motion, is called as to and fro motion or vibrational motion. And the very last is, so let's say one particle is being stuck by other particles. It cannot go for translation. It cannot go for vibration, because everywhere, front, back, left, right, top, down, everywhere is the presence of some particle. So what it will do? It can rotate its own position. This motion is called as rotation motion. So we have rotational motion. And no need to describe, we all know what rotational motion is. So there is a particular axis, along with it will rotate by itself at the rate on axis. So these are some different type of motions due to which energy attached with the motion of an object will be coming in the game, that is called as kinetic energy. And similarly we call them translational, vibrational and rotational kinetic energies. So let me lead you to the part that there we have exactly translational, vibrational and rotational kinetic energies. So now comes the another important term which is named as thermal energy. We have thermal energy and we must know what is the meaning of thermal energy. So guys, thermal energy, it sounds like it might be connected to the heat somewhere or might be connected to temperature somewhere, but believe me, thermal energy is something which is apart from talking about heat or temperature. Thermal energy is actually the summation or the addition of all the kinetic energies which are possessed by the constituent particle of a matter. That means what we can say is that thermal energy is nothing but the addition of all the kinetic energies of elements. Let us suppose I is one of the element and this I may go from 1 to n. That means from 1 to n, if we add all the kinetic energies, kinetic energy 1, 2, 3, 4, 5, 6, 7, if you add all of them, then it provides you the thermal energy of the system, which is because of the particles in motion. Now we will compare some of the physical states. Before that, I must give you an idea about classification. So we have an important topic here, which is actually the classification of matter. And on the basis of this classification, we will proceed with our chapter, knowing so many different categories of the classification of matter. So guys, broadly this has been classified under two categories. One of them is called as physical classification. The another one is called as chemical classification. So basically we can write it also that how are we like dividing something as chemically classified, means this is based on the chemical composition of a matter, and the physical classification is something which is based on physical states of matter. So how many physical states are there for a matter? Broadly there are three, which is solid, liquid, gas. We have plasma, or we also have Bose-Einstein condensate, out of which these three are regarded as characteristic state, or we can say fundamental states of matter. But the rest two are called as non-fundamental states. So fundamental states of matter are solid, liquid and gas, and non-fundamental states of matter are Bose-Einstein condensate, plasma and even a few more. So that was the physical classification we studied till here. Now we have chemical classification. So guys, in chemical classification we have broadly two categories to classify chemical classification. One of them is called as pure substance. Something can be called as pure substance, something can be called as mixtures. Pure substances can also be classified under three categories. One of them is called as elements. We have compounds. We also have ionic compounds. So these are the pure substances. Then we have mixtures, and mixtures are also further classified into two categories: homogeneous as well as heterogeneous. What are the homogeneous mixtures? Which are also called as solutions. What are heterogeneous? Further classified under two categories. One of them is called as colloids, and then we have suspension and colloid. So guys, that's a broad classification of, that is the classification of all the matter. Whatever the matter exists, that's how we classify the matter. So more or less we have to basically focus upon these three states of matter, because these three states of matter contain individual importance. That solid state and liquid state, this combinedly we study in 12th class, 12th standard you will study, and this gaseous state will be studied in 11th class only before thermodynamics, and this is something we not in syllabus. This part of the classification is not in our syllabus. So now we'll move forward, and first of all we must classify these three: solid, liquid and gas. And how come these three are divided or distributed? Yes, we will discuss all the important formulas. Don't worry everyone, I will give you all the important formulas belonging to this chapter, and we'll practice something in upcoming few days. Probably on Monday or on Tuesday we can practice all the questions from whole concept. Okay, so volume. Solids have fixed volume. Volume is also fixed for liquids. 2 liter milk will be 2 liter milk only, but their gases do not have fixed volume, because in whatever the container they are kept, that is actually the volume of gas. So we can say not fixed. Let us suppose if a deodorant bottle is there in which 100 ml of scent or 100 ml of the perfume is enclosed under 200 ml. So you will be considering that 200 ml is actually the volume of this gas. Once it comes out of this container and let's say it acquires the whole volume given to it, which is like the room, so it will be having a volume of the room then. So that is how volume of gases keep on changing. Shape we talk about. Solids have a fixed shape, do not vary. Their shape almost remains same until unless some external force is applied. But liquid do not have a fixed shape. Liquid acquire the same shape in which they are enclosed, and so does the gases. So it is also not fixed. Hardness and rigidity. So guys, solids are actually hard and rigid. Liquids are not hard and non-rigid. Also gases are not hard So guys, what is the meaning of hard? Hardness is a surface property that actually higher is the hardness, lesser can be the distraction or the distance. What we can say is it's difficult to basically change the given configuration of the surface of a particular substance, like scratching it. Especially we measure the hardness by scratching it against the diamond. So diamond on Mohs scale has been assumed to have the highest hardness, and we compare all the relative strengths in compared to diamond only. So that is how we and this is called as mole scale. Mole scale, we compare the hardness. Rigidity is another important topic. Rigidity means something that even upon application of force doesn't change its position of the two. Let's say two positions have been randomly taken in one body. This is one position, this is one position, and I'm continuously compressing it. So if the position doesn't change, I can consider this object as a rigid object. 100% rigid object cannot be found in this universe, but yes, there are something which are very close to rigidity, and solids are specifically very much rigid. They do not change their structure or their geometry very easily. So then we have interparticle force of attraction. So attraction will be maximum in solid. So this is maximum. Then liquids have in between, or we can call it moderate. Then we have gases. Gases have negligible, minimum force of attraction. The interparticle space will be minimum here, moderate here, and then maximum. Thermal energy will be minimum in case of solids, because solids particle do not move that much. Liquid does, so it will become moderate. And gases have the maximum thermal energy, because in gases particles have no attraction. They always keep on moving. Let it be whatever the motion is available to them, they will do all vibrational, rotational and translational. That's why they have the highest amount of thermal energy. Density, generally solids have less density. No, they have high density. Then we have moderate density for liquids, and the gases have the least density. So we can say low densities. Okay, gas is a very low density. That's why gas floats everywhere, but solid are actually fall down like this. So they are heavier, or we can say that they have higher density than liquid and gases. Compressibility is ability to reduce the size of given substance. So reduce the size of a substance called as compressibility. So you cannot compress easily to the solid. So what I can write is they are incompressible. What about liquid? Liquids, are they compressible? They are also incompressible, because they already have very lesser space between them, so they cannot be compressed down. They are incompressible. But gases are highly compressible. Why they are highly compressible? Because they have vast space between the particles. That's why they can come closer. And fluidity, solids are non-fluids, but these two are fluids. So that's how we do. So note it down everyone and try to find out the differences. Okay, fine. Now, after completion of physical classification, we have two more states of matter, which right now are not in our syllabus, but I can give you this idea that whenever you ionize a gaseous sample, let's suppose hydrogen, or this is helium, and upon subjecting it to high voltage, it produces this. So guys, this is also gaseous, this is also gaseous, and the mixture of this mixture of, let us suppose, helium cation and electron together continuously accepts energy and releases out energy, and it looks like bright in appearance or flashy in appearance. We call this mixture is called as plasma. This is called as plasma. This is also called as fourth state of matter, and it is strongly influenced by electric and magnetic field because of the presence of ions there. Ion can have unpaired electron, can show magnetic property. Ions can also show electric property because of the charge present to them. That plasma doesn't have a fixed shape or volume, and they are very less dense than solid and liquid. And approximately 95, this is most loving part of this line, this entire topic, that 95%, over 95% universe is actually assumed to be composed of plasma, because plasma can like occur in natural life in so many ways, such as neon sign bulbs, lightning, polar aurorae, fluorescent lights, then solar wind, welding arcs, earth ionization, ionosphere, etc. That's about plasma. I would like to write as homework that if you are more curious, do it the homework, try to find out what plasma is, try to more and more learn about plasma. Then we have Bose-Einstein condensate. Yes, next. So we have plasma. So guys, this is not how a plasma look like, believe me. It doesn't look like in fact anything, but more or less it is just opposite to the theory of plasma. Plasma's theory is completely opposite to Bose-Einstein condensate, and we are just saying that let us suppose you have been given up with a gas, and if a gas is actually subjected to 0 Kelvin, then it becomes what? Perfectly crystalline solid. And we call it as Bose-Einstein condensate. So this idea came in the mind of Mr. Satyendranath Bose a long back, when so many resources were not available in India, and he discussed the idea with Einstein, saying that if we are providing energy to a state of matter and it becomes highly energetic just like plasma, in a similar way, if we decrease down the temperature and we reach somewhere to 0 Kelvin temperature, can we stop the movement of particle? Can of this particular substance become an ionic compound? And if yes, then this is called as Bose-Einstein condensate. Now you people, we have a plenty of things written down over here. Try to read it out and try to write it down first of all, and then we'll move to the next topic. We have pure substances with us. What are pure substances? So guys, the very first category comes with pure substances. Pure substances are the one which are actually made up of the same type of element. So I am writing the definition here. Pure substances are those kind of matter made up of a single type of constituent particle. So guys, it might be having so many number of particles, but the particles nature is exactly the same. All the particles are exactly similar to each other. So such type of substances are called as pure substances. And the very first category among these compound is element. Number one is actually element. So how are elements pure substances? Because elements are composed of identical type of atoms. An example is copper wire, aluminum foil. So guys, remember that till date 118 elements have been discovered. Till date 118 elements have been discovered, and they are written in the form of modern periodic table. Got it? So that is the classification of pure substances, and the very one of them was element, and then element part is absolutely covered. Clear? Number 2 is called as compounds. We have compound with us. So compound is actually made up of two or more type of elements which are attached to each other in a chemical combination by a fixed number of fixed mass. So that is what the definition is, that compound are made up of two or more elements in a fixed ratio by mass. Then the properties of the compound differ from the individual elements. Example is NaCl. So take this example, everyone. H2 plus half O2 gives you H2. So check it out, guys. These two are elements because these are made up of same type of atoms, only same type of atoms. So H, we can call H2 as like it's a fuel, it's a supporter. So this is a supporter of combustion, but H2O is actually extinguisher. Now can you imagine this part? Hydrogen and oxygen are some fuel and something which is required to burn the fuel, but H2O is actually an extinguisher. This has a completely different property from the combining one. So that is what the definition of a compound is, that compound is actually made up of some molecules, and in a molecule two or more atoms are connected together by strong chemical bonds, and this type of pure substance is called as compound. So guys, please note it down. Let me add one address, guys. Allow me a moment. MIC है ना, MIC लिखते हैं. Yeah, some. Now we have with this continuity we have, guys, the third thing is called as formula unit. So guys, till now what we have come across a conclusion that if we talk about atoms, allow me, done. Yeah, so what I'm telling is an element is actually a matter. There is a constituent particle in it by which this entire matter is composed of. And we can take some examples also. The example will be written here. So guys, just assume that one of the matter is our element. The constant particle of an element is an atom. This will give you the clarity about entire mole concept, that how come this conversation of mole concept, atom, atomic mass, molecular mass, molar mass, these all have come up from. So element has its constant particle as an atom. Take this example. Let's say element is hydrogen. Let's say element is hydrogen. Its atom will be hydrogen H, or it can also be taken as H2, because we know that there are some of the elements in which instead of atoms there exist the molecules, and hydrogen is one of them. So instead of hydrogen, let me just write some other, such as iron. Arey yeah. Take the example of iron. So Fe atoms, Fe is the chemical symbol, and these atoms are actually example of constant particle. Let us take one more category, as in like element. Now we will have let's say compound. So compound will be having a constant particle of molecule. Compound is actually nothing but the collection of so many molecules. So guys, take the example. Let us say compound is water. Water itself is can be considered as a compound. So one of the H2O molecule will be considered as a constant particle. See how easy is this? But in the similar way, we can't write it for ionic compounds. So let us suppose ionic compound is there. An ionic compound has its constituent particle as ions, no doubt ion, but these ions, specifically ions with a proper smallest whole number ratio and a neutral unit, is called as formula unit. So we consider the formula unit as an example. So let us take this part. This ionic compound is actually, let us suppose sodium chloride is an ionic compound. Then its constituent particle will be a unit that is called as NaCl unit. Another example could be magnesium sulfate. Then one of the MgNSO4 unit will come as a part of example. Hopefully this part is absolutely clear to all of you. Now there's one more point I want to add from here. This point says that first of all I must write a note, because not all the elements exist in the form of atoms. Some elements exist in molecular form, rather they are having same type of atom, same kind of atom, chemically combined together. So guys, what is the meaning of this statement is example. So guys, earlier we were writing Fe, Al, argon, helium, we had chromium, manganese, sodium, potassium, rubidium, cesium, etc. Even carbon, everything of these atoms, these all are the type of atoms. Their collection will be called as an element, but some of the element exist in molecular form, such as H2, Cl2, Br2, I2, P4, S8. So they are also containing a same type of atom in it, but these atoms are chemically bonded or chemically combined. So that is the beauty of this term we call element. That element can be classified under these categories: one which is composed of simply atoms, one which is composed of homoatomic molecules, like this. So there is no different atom coming in this formulation, and that's why they all are kept under the category of elements. Next, so guys, I was about to explain what is the meaning of formula unit. So now you all have this idea that, let us talk about this metallic rod. Let's suppose this metallic rod, this iron rod, this is an iron rod, and an iron rod is actually an element. An iron rod is actually an element and it is a matter, but all the particles it has been made up of, these are called as the constituent particles, and these are iron atoms, Fe atoms, which are nothing but the constituent particles. Hopefully you people are pretty much sure and confident about the concept of element and atom. Then another one is this water. So what do we observe in water? That's that this whole bulk or the mass is actually water, which can be regarded as compound. So the category of classification of element, it fits into a classification of matter, it fits into compound. And we can also find some of the molecules suspending or moving around, and they all are the H2O molecule. An H2O molecule is actually the particle of this compound. Got it, guys? Now there is one more thing, and that is actually an ionic compound. Ionic compound, sodium chloride. We have an ionic compound, sodium chloride. But the classification of the ions is not very simple. There is no separated ion. So take, I'm just writing it as, please turn over, please reach to the next page. Okay, right after it, let's reach to the next page. Well, I'll explain the part that every single cation and ion are attached to each other with a force of attraction called as ionic bond or ionic force of attraction or electrostatic force of attraction. So there is no such an individual unit. So what we can say, no individual separated particle here. So in such conditions, we need to give one particle. So how are we supposed to give the particle? We have this term called as formula unit. And now let us read the formula unit. The smallest whole number ratio of cation to an ion in an ionic compound is called as formula unit. So just simply take this example. In sodium and chloride, we have plenty number of sodium, plenty number of chlorine, but the smallest ratio examples. So we will write here ionic compounds, and we'll write there formula units. So take this example, everyone. Ionic compound, let's say sodium chloride is one ionic compound. The formula unit will become NaCl. If the ionic this compound is magnesium chloride or magnesium sulfate, I have already taken, I'll take bromide. It will become MgBr2 and so on. So we have simply changed ourselves when we go in the transition of 10th to 11th standard. In 10th standard, we also used to call these compounds as compounds, and their like NaCl and CaCO3 or MgCl2 as their molecules only. But now we cannot call it as a molecule, because a molecule can be separated, can be extracted, or it's an individual unit. But in ionic compound, there is no individual particle that exists. Instead, the ions are attached with the oppositely charged particle and being bonded in all the directions, and that's why we have to consider one shortest, simplest formula that contains, which is neutral in electrical charge. Have I mentioned this part? Neutral in electrical charge, and it must contain the lowest number possibles and whole numbers also. It should not contain any fractional numbers. Now I'll take you to some important questions, so as we can clear our doubts, whatever we are right now facing through. So carbon dioxide can be considered element, compound, or ionic compound. So it's a constant particle, so particle belongs to compound. Zinc sulfate is an ionic compound composed of metal and non-metal. So it's a particle, it's a formula unit of an ionic compound. And iron itself is an atom. Atom belongs to element. So guys, what should be the correct answer? CO2 belongs to B. First answer is B, second is C, and third is A. I think second is the correct answer. We have mixtures then. Now we have come to the chemical classification of elements, and the another classification is called as mixture. So guys, what is the meaning of a mixture? Mixture means a combination, a physical combination. Physical combination means we are not chemically reacting two things, we are simply adding them together, and these things are already pure substances. So its mixture is actually like collection or combination of pure substances and variable combination. Variable means which we can vary. So let me just give you an idea, guys. So let us suppose there are two things with us. One of them is hydrogen gas, plus we have oxygen gas. We did two things. We are doing chemical combination. What we are doing is chemical combination. There are some certain conditions under chemical combination, that they are combined in the fixed mass ratio of hydrogen to oxygen as 1:8, and we are chemically allowing them to react. So as a result of chemical combination, we got H2O, which is compound. We will receive water, which is nothing but a compound. If we do the same thing but in a different way, if I do the same thing in a different way, same thing as in we are mixing these two gases, but now we are physically mixing them. We are going for physical combination. So in physical combination, what we will observe, that it's not fixed now, so it's a variable combination. Variable combination is there, no fixed ratio like this, and as a result you will get simply a homogeneous mixture. We will receive a homogeneous mixture of these two gases. No compound is formed. So guys, this is what the reality is, that there could be two type of combination. One of them is called as physical combination, another is called as chemical combination. In chemical combination, a new substance is formed, which is called as compound, and in physical combination there is no new compound, no new substance is formed. It's just a mixture of two gases. Now we have solution. Solutions is one of the category of mixture. We also call them true solutions, or we also call them homogeneous mixtures. So these are some other names that we also use for the homogeneous mixture. So homogeneous mixtures have very small size of the particle. Specifically we are talking about solute particle, and solute particle has one lesser than 1 nanometer. 1 nanometer, even lesser than 1 nanometer. They do not show any Tyndall effect. Tyndall effect, what is Tyndall effect? Guys, have you ever heard about Tyndall effect? Sir, when we will complete 11th portion? By which month? I can't commit anything right now, Ashwath, because my target is pretty simple, that every week we'll cover on an average 2 chapters, because 1 week will be having lecture where I'll completing theory. The another week I'll go for practicing and some PYQs part. The similar pattern will be followed day by day. Once we'll like cover some of the chapters initially, then we'll come to increase the frequency of our lecture. Right now I cannot commit anything, so just focus on like concept, try make your own notes, stay confident out of it, and believe me, this thing is absolutely enough for you, in not just in your mains but also in advanced, and we'll also incorporate some advanced questions while we're going for the solving or practicing part. Okay, it is sufficient for JEE mains, not just JEE mains. Chaudhary Ashish, this will also be sufficient for JEE advanced. So up to that we'll provide you the complete content. Now I'm coming back to my topic. I was asking you, have you guys ever heard about Tyndall effect? So you will say no. So what is Tyndall effect, guys? Tyndall effect means, so let us suppose this is let's suppose what is it? Sand particles suspended in water. These are sand particles suspended in water, and this is a torch we are having, and torch is having lights coming in all directions. So guys, what will happen? This light will go, this will strike it, and it will get deflected, and then observer is checking from this place, and what do we observe is the path of light is visible in किसमें? In this solution, in mixture. The visible path of light is called as Tyndall effect. Tyndall effect. Similarly, guys, take another example. And here we have sodium chloride dissolved in water, and here might be the observer, and the path of light is coming like this. This is your torch, but you will see observation is the path of light is not visible inside mixture, showing no Tyndall effect. So there will be no Tyndall effect. This is what we call as Tyndall effect. Chalo. Now coming back to our topic, yeah, because the particle size is very small, light cannot strike to this particle, leaves this particle, and that's why Tyndall effect is not visible to us. We cannot see the particles. You can try at your home also. That sodium chloride solution, which is salt in water, cannot show you Tyndall effect, but milk, soap solution, suspended dust particles in air, everything can show you this Tyndall effect. We have rubbing alcohol, which is one of the alcohol with water, and sugar syrup, saline water like salt plus water. Aqueous copper sulfate is one of the good example. Aqueous iron sulfate is one of the good example, etc. We had which category with us? Homogeneous mixtures. Now we'll come to the another kind of mixture called as suspension, one of the heterogeneous. So heterogeneous are further classified into two categories. One of them is called as suspension, the another one is called as colloids. So suspensions are heterogeneous in nature. They have large size particle which is actually greater than 1 micrometer, and that's why they can strike directly with the light, incoming light, and they can show the path of the light visible inside the mixture, and that is why they show Tyndall effect. The particles settle after some time. You can mix it up, but you leave it, the particles of sand will settle down. Example is muddy water, sand and stone, rice and pulses, dal chawal. This all comes under the category of heterogeneous mixture. Right? Why not? Now we have mixtures, everyone, mixtures, and the third category of mixture, and that too under heterogeneous mixtures, we have colloids. What are colloids? The example of milk is here, everyone. Heterogeneous mixture, they are also heterogeneous. Colloids actually they look alike homogeneous, but actually are heterogeneous. They look alike homogeneous, but actually are heterogeneous. They have particle size in between, like they are greater than 1 nanometer, but they are smaller than 1 micrometer. They show Tyndall effect. They particles don't settle, and they do Robert Brownian motion. We call it Brownian motion. They will understand this whole theory of colloid in 12th standard. There is a chapter by the name of surface chemistry in which specifically we study about colloids. The huge chapter is there, complete explanation of this topic. But right now just take an idea about the classification of matter, and we have completed our matter till here: milk, soap solution, blood, tea, juices, coffee, etc. These all comes under the category of colloid. Even butter, cheese, these all are also example of. Ice cream is also an example of mixture. Which mixture? This mixture, colloid. So this first part is now covered. Let us reach to the sum of questions will be done here, and in my practice session I'll bring more and even more questions, but till here we have to focus here at which of the following is not a pure substance. So not a pure gold is pure, it is an element. Pure water is pure, it's compound. So let me write, pure gold is actually an example of element, pure water is an example of compound, carbon black is also an example of an element. But look at this, pure milk is a colloid which come under the category of heterogeneous mixture. So the correct answer should be 3. But simple questions are there, everyone. Very simple question. One more interesting question for us, that which of the following is not a true solution? Which of these is not a true solution? That means not forming a homogeneous mixture. So salty water is homogeneous. Sugar syrup is also homogeneous. Lemonade is also kind of homo, but muddy water comes under the category of heterogeneous mixture. That's why correct answer should be 4. All clear, guys? Tyndall effect will be shown by, Tyndall effect can be shown by heterogeneous mixture, either of the colloid or suspension. The correct answer is 4. And guys, there we end with this one very important part till now, that was your classification of matter. So you all have come across what is a matter, how come we classify it physically and chemically. In physical classification, we had solid, liquid and gas. We have pure substances and mixtures in under the classification of chemical classification. In pure substances, we also had three important categories of elements: compounds, ionic compounds. Elements are made up of atoms, compounds are made up of molecules, and ionic compounds are made up of ions. But these ions together are called, in a neutral unit, they become formula unit, the smallest neutral unit, which is like containing both of the counter ions. And then in another classification of mixtures, we had homogeneous and heterogeneous, and that is what till here we have finished. Now there are 6 laws of chemical combinations that you have to study. 6 laws of chemical combination that we will study. You people have already covered this part probably in your previous sessions, but not a problem. We'll discuss them right now and even with more detail. The very first of them is called as law of conservation of mass. But before that, let us understand what is the meaning of law of chemical combination. The law of chemical combination means that in chemistry, we study that change of matter from one form to another, and these changes sometimes occur as a result of the combination of two or different type of matter. And there are certain rules which have to be followed while two or more elements are combined together to give you a certain new substance. Take an example: C plus O2 gives CO2. So guys, this is called as chemical change. This is nothing but a chemical change. So these are two elements, two different elements. They are chemically combined and they produce what? A compound with different property. So that is what we have to follow, certain rules while preparing compounds out of the elements. And the very one rule of them is called as law of conservation of mass, that mass in this universe cannot be created nor be destroyed. It can only be, it's conserved in nature, right? So mass of an isolated system cannot be created nor be destroyed, but can be transferred one form to another. Yeah, and that happens one form to another. So like carbon plus oxygen gave CO2, right? So guys, in total, you will find that total reaction before and after a chemical reaction will be what? Same only. Okay, the total mass before and after a chemical reaction will be the same. But this is not seen in terms of the nuclear reaction or radioactive reaction, where some of the mass is basically converted into energy. This is called as the mass defect, and delta is basically the energy, and C is the speed. Speed of particle. So this is the limitation of this law. We have a simple question, everyone, for every one of you. We have a simple question here, and just to give you an example, just to give you the try of this particular concept called as law of conservation of mass. So 15.9 gram of a sample of sodium carbonate is heated and added to a solution of acetic acid weighing 20 gram, and then two substances react, releasing carbon dioxide gas to the atmosphere. And after the reaction, the content zoop. I'll give you the answer. How are we gonna to do it? We have two things with us. One of them is called as sodium carbonate, which is reacting with acetic acid. We are not supposed to write down the chemical formula here. We can easily Name them and we can find out whatever it is required, since it is following law of conservation of mass. So we have, let's suppose, some residue, and the one is carbon dioxide gas which is releasing out. Guys, we have been given with their some ideas of their masses. We had 15.9 gram here of sodium carbonate. We had 20 gram of acetic acid. We have some residue left which is 29.3 gram, and let us consider this as x gram. So guys, we all know the total mass before and after will be the same. So now simply apply law of conservation of mass. So this will say that 15.9 plus 20.0 is equals to 29.3 plus x, and that's how you will get the value of x. So how much is x, by the way? So this is your 35.9 minus 29, 6 point something, I guess. I think the correct answer should be 6.6. C. So this is something that you will do by your own, a similar kind of question as a homework. Next is law of definite proportion. So guys, right after the completion of this session, you will download these notes. After downloading, just make your complete notes first of all, and then try to solve all these solved questions. And right now, after completion of this lecture, since we are gonna to conduct another session in couple of days where we will be solving all the questions, we will be solving all the practice part of this chapter. I want to inform you that you must do solved problems by your own. Wherever I'm writing HW homework for you, you got to finish that part first. Now, another law is called as law of definite proportion. The meaning of definite proportion is very simple, guys, that whenever two elements are combined together, their chemical combination will occur in such a way that their masses should bear a simple whole number ratio between them. Simple whole number ratio between them. So this is how everything works. So guys, let us take this example. If any example is given here, so let us take this example. Let us suppose hydrogen plus oxygen are combining together to produce water. So guys, you all know that maybe with the time you will come to know that this is actually 2 grams which is combining here, and here it is 16 gram which is combining. So if you take the ratio, it is 1:8, which is a simple whole number ratio. There could be another example if you want to take. C plus O2 gives you CO2. So let us suppose this is 12 gram we are using, and no doubt this will also be 18 gram. Okay, law of conservation also it is followed, no? 2 plus 16, 18. So let 12 gram is here and 32 gram is here. So no doubt this will become 44 gram. So then important part is this ratio is how much? 4 3 ja, 4 8 ja, 3 ratio 8, another simple whole number ratio. So this is your law of conservation, law of definite proportion, that whenever two or more elements are combining together to create or to form a compound, they do so in a fixed number of their atomic mass or a fixed number of their masses. Here is one question. So the question might look like you very difficult, but believe me, this is very easy. What is it saying? That two gases sample were analyzed. One contains 1.2 gram carbon, 3.2 gram oxygen. Another contains 27% and 72% of oxygen. Then what experimental data is according to with? So guys, you always remember that according to law of definite proportion, we have their masses are always fixed, that percentage composition by mass is constant. Percentage composition by mass will always be constant, because we all know that they follow a particular ratio. So what is the percentage of carbon if we are to find out in the first example? So percentage carbon will be how much in first case or in first sample. So percentage carbon is 1.2 gram divided by 1.2 plus 3.2 into 100. How much does it come? 1.2 divided by this is 4.4 into 100, and it will nearly be coming up as 27.3%, which is exactly equals to case number second. It is also equals to the case number second, and thus it follows what? Law of definite proportion. No other information has been given to us. This will be follow law of definite proportion. This is something that you will do by your own homework. Then we have limitations of this law of definite proportion, that guys, this law doesn't work in the case of isotopes. Take this example. There is H2O and D2O. Both of them are same compound. These two are same compound, water. Same compound, water. So hydrogen ratio oxygen will come up as 1:8, but deuterium ratio oxygen, deuterium is mass of 2, so 2 ratio A4 ratio 16, so this will give you 1:4. Not fixed, different. That is a failure. Hopefully this part is absolutely clear to all of us. Then we have law of multiple proportion, LOMP. Guys, this is very easy to say, and let me explain it very easily in my way. The reaction says, this statement says that whenever two elements are combining together with a third element, so when one element combines with the another element to form more than one different compound, like more than one compound, then the mass of one which is combining the constant mass of another will be at a simple whole number ratio. That means, guys, let us suppose hydrogen and oxygen are combining together and they form two different compounds. One of them is, let's say, H2O, another one is H2O2. So here what you find is hydrogen ratio oxygen, and here is hydrogen ratio oxygen. So hydrogen, number of hydrogen and oxygen are 1:1, 1:2. So guys, it is saying that the element which is combining with the fixed mass of another. So where can you have the fixed mass? Where is the fixed mass? Whatever it is having, this hydrogen is having the fixed mass, right? Hydrogen is having a fixed mass here. Then the element which is combined with the fixed mass of the other will bear a simple whole number ratio. Then 1:2 will become what for oxygen? Simple whole number ratio. This is called as law of multiple proportion. Hopefully this example is enough, and if not, let me give you one more example and with the definition also. Let me give you one more example, everyone, which is very important, which is very easy also. Let us suppose carbon and oxygen are combining together to form two different compounds. One of them is carbon monoxide, another one is carbon dioxide. So since we know that here carbon is fixed, carbon is actually same in both sides, then oxygen will bear what? Oxygen will bear a ratio of 1:2, which is again simple whole number ratio. Correct, guys? I want to ask you one question. N2O and NO2, do they follow LOMP? NO2 versus N2O. Sir, when will you teach hydrocarbon chapter? Hydrocarbon chapter is already taught to you in one shot, and specifically to those student previously few days back only I taught you hydrocarbons, guys. So you can scroll down, you can find it out. If it is very much in urgency and then you are facing your exams nearby, you can go to that particular chapter. It's a huge chapter I have explained in one shot along with some good practice questions. But if in 2026 you are preparing, then hydrocarbon will come accordingly. It will take time. So there we have, do they follow LOMP or not? So guys, in such condition, what you can do, we will write down that this is N2O and this is NO2, but there is nothing which is having in common. So we can take anything and can multiply it by 2 to make any single element equal in both sides. This will become N4O2 and this is your NO2. So now what you can see, that oxygen is having the fixed mass. Oxygen is having what? Fixed mass. So for this fixed mass, the ratio of these two will become what? Nitrogen will be having 4:1, which is again simple whole number ratio. Guys, we will follow the sequence, hai na? So even equilibrium or whatever you are asking me, everything will come according to the sequence. So that is it. So guys, put a note down over here. Just take a note over here that all the elements of all the compounds of nitrogen and oxygen follow law of multiple proportion. So now this could be whatever the nature of the compound is: nitrous oxide, nitric oxide, nitrogen dioxide, dinitrogen trioxide, dinitrogen tetroxide, N2,5, etc. all follow LOMP, law of multiple proportion. Then we have limitations here. We have limitations of law of multiple proportion. That this means that law is valid for basic chemical reaction, and it doesn't work where we have complex molecules, heavy molecules, because they will not have simple whole number ratios. An iron combined with oxygen producing ferrous oxide and ferric oxide. This data illustrates. Very simple, guys. Ferrous oxide. ferric oxide. What did I tell you? Make anything equal, so you can make it Fe2O2, you can make it Fe2O3. What about the ratio? This is the fixed mass. They are having what? Fixed mass. So remaining two are having what? 2:3. Simple whole number ratio. Hello. So I went for actually lunch. It's a late lunch, I must say, but no other options was pretty much available by the time. Now we'll move forward for this question, and this question actually I would like expect you people to try it by your own, because anyways I can give you the idea. Water contains 11.1% by mass another and 94.07, the chemical formula. Anyways, we'll study later in empirical formula. So guys, this is belonging to empirical formula. Right? How? Because hydrogen and oxygen. Hydrogen has a mass of around 11.11 grams. This will become 94.07 grams, and we will divide them by their molar mass. This will be 11 only, and this will become 5.5. So nearly nearby whole number ratio is actually 2:1. So 2:1 means formula will become H2O. Anyways, this is a simpler question and anyone can answer for this question, but I would expect you people to understand the concept later on in the empirical formula. Okay, I already mentioned this part. Now we have fourth law called as Gay-Lussac law. Gay-Lussac was a scientist, and he said that whenever gases react or produced in a particular reaction, they do it in a simpler whole number ratio. So guys, take this example. N2 plus 3H2 produces 2NH3. This is one of the very important process called as Haber's process. This is a chemical reaction here. This chemical equation has been written down, and these all are gases. So the ratio of their moles, they do it in the simple whole number ratio of their molecules. So this ratio can be 1:3:2, making sure that they are at constant temperature and pressure also. Take another example. We have SO2 plus Cl2, and we have SO2Cl2, sulfuryl chloride. This is gas. So you want to check out the ratios. It's simply 1:1, which is another simple whole number ratio. That was Gay-Lussac law. And now we have one question on Gay-Lussac law. How much volume of oxygen will be required for the complete combustion of 40 ml of ethane at normal temperature and pressure? Not so easy question, guys, specifically for those students who are studying this topic for very first time, because even the balancing and everything is involved in this chapter. So let us take this example of C2H4 plus oxygen. As many number of carbon will produce the same number of CO2, so 2 CO2. Half of the number of hydrogen is produced as water, 2H2O. Number of oxygen are 2 plus 4, 6. So 6, it will become 3. So this is a balanced chemical equation. This is a balanced chemical equation. Anyways, I was about to explain one more part over here. The volume should be in simple ratio. The ratio, this is actually molar ratio. This is actually molar ratio 1:3:2, and this is also equals to the volume ratio. So if you write down the volumetric ratio, this also give 1:3:2, and this can be explained using ideal gas equation. So there is a gas called as ideal gas, which follows this equation of PV is equals to nRT. So at the rate constant temperature and pressure, volume of gas is directly proportional to the number of moles. So what we can write is, whatever the ratio of volume will be there, that will be the volume of, that will be the ratio of moles also. So N2 plus 3H2 producing 2NH3. All of them are gases. So let us suppose their ratio of the moles, and we can even check it also. Molar ratio, mole ratio 1:3:2. So the volume will also be like V ratio 3V ratio 2V. So guys, whatever the volume you take, you can manage it accordingly using this proportion. So now we can solve this question. We have this question. We need to know only we got to know about their molar ratio. So molar ratio is the ratio of the stoichiometric coefficient. Stoichiometric coefficient is something which is written over here in the balanced chemical equation. 1:3:2. So how much volume of oxygen will be required for complete combustion of 40 ml? So guys, volume of oxygen upon volume of ethene is already given to us in the moles of 1:3. So 3:1 actually, 3:1. So volume of O2 will become what? 40 into 3, 120 ml. Correct answer D. Then we have limitations, that this is only applicable up to ideal gas. Gay-Lussac law holds good for real gases, doesn't hold good for real gases. And if it does, then it does it for the high temperature, low pressure, because a real gas behaves ideally. A real gas behaves ideally only at low pressure, high temperature. Also, the ratio of the pressure to the temperature deviates at high pressures. So at high pressures, this law doesn't work. Gay-Lussac. Next comes Avogadro law. Avogadro law says that equal volumes of all the gases at same temperature and pressure should contain equal number of molecules and atoms may or may not be. So this is another very cool. So guys, as we all know, so let us take this example of helium, hydrogen, CO2, CH4, no, NH3, CH4, let us say PCl5. So guys, in these example, simply write that the, let's say, equal volumes we are talking about. They all are having volumes are equal, and pressure and temperature are already constant for all of these, and the volumes are, let's say, V, and we all know that number of moles is direct proportional for an ideal gas. Right now we study for an ideal gas, volume is directly proportional to number of moles. For an ideal gas, we know that number of moles, volume is directly proportional to number of moles. So number of moles will also be constant. So if we talk about number of moles N, they will be N, 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 and N. So since they all are N and N, now we will say that the molecules will be. So molecules will be how much? Number of moles multiplied by Avogadro number, that we'll come to know about it very soon. So N multiplied by Na, or let us say we are saying it, number of molecules be capital N, capital N. And now look at the final part, guys. They all are having exactly same number of atoms, molecules. But what about the number of atoms? Sir, atoms may differ. Atoms may differ because every molecule contains some number of atoms. Helium contains one number of atoms, so it will be N. This contains H2, 2 atoms in it, so it will become 2N. Then it will CO2, 1 carbon, 2 oxygen, 3N. NH3 we have 4N. CH4 5N. PCl5 6N. Now you can check the definition and you can observe it by your own that number of atoms may differ. Number of atoms will be different, but number of molecules are exactly the same. This is called as the law of Avogadro's law. Next is a tire consists of 10 moles of air and occupy 40 liters of the volume, loses half of this of the puncture. What is the amount of air left? Very simple, yeah. As I told you that loses half of the volume. So guys, we all know that volume is direct proportional to number of moles. So we'll give you V2 by V1 is equals to N2 by N1. So V2, let us suppose initially 40 volume was there, half is gone, so 20 liter is gone, 20 liter is remaining. Number of moles remaining will be N2. Number of moles initially taken were 10, so that is why N2 comes up as 5 moles. So using Avogadro's law, we have calculated, we have find out easily what is the number of moles of remaining gas. Then we have 1 molar volume of an ideal gas, guys, which is also going to come in our upcoming derivations or upcoming formulations for number of moles. So whenever an ideal gas is given to us, so 1 mole of an ideal gas acquires 22.48 STP. Let us first discuss about STP, called as standard temperature and pressure. Standard temperature and pressure. So standard temperature is how much? 0 degree Celsius will take, or we can call it 273.15 Kelvin. Pressure, usually we take 1 bar, so STP. And volume occupied by gas, for Vm, we will call molar volume as Vm, will be 22.4 liter per mole. Talking about NTP, we had STP, then we have NTP. Normal temperature and pressure. Guys, this value may vary. It may have some different values also. And every individual chapter in chemistry can have different terms of standardization also. So it may vary. Temperature usually take as 20 degrees Celsius, which is also equals to, now you add 273.15. So 293.15 Kelvin. Pressure is how much? 1 atmosphere, because normally normal atmospheric pressure will be taken, and molar volume will come up as let me check, 22. Check it out. Next is calculation of the molar volume. So guys, how can we calculate it, molar volume? So molar volume of an ideal gas at the rate standard temperature and pressure. How to find out? Do one. We know that PV is equals to an RT. So if N is equals to 1, volume becomes Vm, molar volume. So molar volume will be how much? N R T by P. N is what? Number of moles, 1 mole. R is, guys, we usually take 0.0821 liter bar liter mole inverse Kelvin inverse 831. How much is temperature? 273.15. Kelvins always take in Kelvin. How much is pressure per bar? You calculate it out and you will get the value of 22.4 liter mole inverse. So that is how we derive it, that 1 mole of any gas, if it is behaving ideally, occupy 22.4 liter of its volume at standard temperature and pressure. So that's done till now. Now the last and final law, called as law of reciprocation. Law of reciprocation. That means if two different elements combine separately, now try to understand, it is very confusing while we it's very confusing, even its definition wise it's very confusing. So read it out once more, give it a reading. So it has been written that when two elements are combining separately with some same element of weight of third element, then the ratio of masses which they are combining will either be the same or will be a simple multiple of the mass ratio. So anyways, I will give you one example here and then I'll ask you to learn whatever the trio is given for 3 elements. It will definitely be following law of reciprocation. So take this idea, guys. This is saying that, let us suppose we have an element carbon and hydrogen, and they both are combining with oxygen. They both are combining with oxygen to produce One will produce CO2 and another will produce H2. You all remember 1:4 was the mass we were earlier using, 1:8. So let us suppose this is fixed and this is fixed of like 16 gram. Fixed. So this is fixed of 16 gram. So according to this, how much mass of hydrogen will be taken? 2 gram. And carbon will be 12 gram. So let me see, CO2. Not CO2 will not be this 12 gram. If it is 16 gram, then 2 is fine. That CO2, O2 is 32, carbon is 12. 3:8. 3:8. So this will be like 6 gram. This is actually 6 gram. So guys, this is what it is saying, that the ratio of mass of carbon to the hydrogen will also be a simple whole number ratio. 6:2 is actually 3:1. The ratio of the masses in which they do so is either different or the same. Okay, that means, so guys, this is what it is trying to say, not this. It's saying that the mass of carbon ratio mass of hydrogen using this combination will be 6:2. This is 3:1. But if carbon and hydrogen react, they will form what? CH4. And whether the mass ratio is 12:4:1, that is also 3:1. So guys, this is saying that either it will be the same or will be a simple whole number ratio in which they are combined together. So they are combined together in 3:1. We are getting this data from combination of another compound as 3:1. This is same. This is a bit confusing, everyone, but believe me, if you follow me like what I'm saying, you will definitely be getting the correct answer. So guys, this is how you have to remember this law, that whenever 3 elements are given to you, let us suppose these 3 elements are sulfur, oxygen, hydrogen. One trio will be given there, one trio. So these two, and these two can make separate compounds, like sulfur oxygen will make SO2, hydrogen will make H2O, and this will make H2S. Whenever any kind of this is given, this is called as the law of, any kind of trio is given, you can say this is the law of reciprocation. This is called as the law of reciprocation. Then limitation: in the presence of elements of the isotopes, the proportion may be different, correct? In the presence of isotopes, and as a result, the same isotope or combination of the isotope should be employed during the synthesis of the compound. Anyways, yeah, I'll leave it, man. Guys, now we have come to Dalton's atomic theory. We have Dalton's atomic theory. We already have exhausted ourselves and taken too much time, so I won't take too much of your time here. Just give it a reading. What did Dalton say? In 1808 he proposed his theory. Let me write. In 1808 John Dalton said that a matter is made up of tiny indivisible particles. Indivisible, which cannot be further divided, is called as an atom. The atom can be neither be created nor be destroyed, and atom cannot be divided into subatomic particles also. All the atoms of specific element are identical in mass, shape, size, and all the properties. Atoms of different elements are exactly different from each other, nothing similarity from each other. Atoms of different elements can combine together to form the whole number, they are combined in whole number ratios to form the compound, and atoms can be rearranged, recombined, and separated in a chemical reaction. These are the points of Dalton atomic theory. So guys, take them as point 1, point 2, 3, 4, 5, 6 and read them. Read them. Read them. I'll be back in just couple of minutes. Read all the points. So you all have read it. This is your Dalton's atomic theory and some of the points. So now we'll come to the limitations of this Dalton atomic theory. Since we know that an atom can neither be created nor be destroyed, but atom can be subdivided into its subatomic particles such as electron and positively charged nucleus. So number two, it doesn't account for isotopes, because isotopes of an atom isotopes of an element are those atoms which have same atomic number because they belong to same element but different atomic masses. So if something is having different atomic mass, that means all of the atoms of same element are not identical. The another one is doesn't account for isobar. Now isobars are actually atoms of different element which are be having same atomic number, same atomic mass. Take this example. So if I talk about the isotopes, so let us suppose isotopes are potassium with an atomic number of 19 with an atomic mass of 39 and potassium with a 19 and 40. These two are actually isotopes. Then we have isobars, elements having same atomic mass but different atomic number because they belong to different elements. Atoms of different element these are. So take this example, argon with atomic number 18 and 40 atomic mass, potassium 1940 and calcium 2040. All three are isobars. Then it also doesn't account for the allotrope. Allotropes means different forms of same element has different rate of reactions, different chemical reactivity, and elements not need to be combined in simple whole number ratio to form compound, because this can be explained using existence of non-stoichiometric. This can be explained using non-stoichiometric compounds. So what are these non-stoichiometric compounds? Example, let's say LNH 2.95, iron 2.87, etc. These are non-stoichiometric compound. So that is it, guys. That was the basics of this chapter. That was classification of a matter, and then we had Dalton's atomic theory and laws of chemical combination. Now we have entered to the major part of this chapter called as atomic mass. No doubt mass of an atom is called as an atomic mass, very easy to define, but an atom is very small in size, which has very small mass in magnitude, which is like 1.6733 10 to the power minus 24 gram for hydrogen, which is very small, then like this and then like this. So now it is very difficult to remember these masses, writing them, reproducing them, learning them. It's very difficult. So scientists gave an idea, and I will directly come to the conclusion only that we should make a reference atomic mass, and using that reference atomic mass we will compare all the masses, atomic masses of all other, and that will be called as relative atomic mass. So first of all we must know what is that mass. So that reference mass is actually that reference mass, what they took is actually 1/12 mass of carbon C12 atom. What is the meaning of C12? C12 is that carbon atom which is having atomic mass of 12 unit. Anyways, So how much is this, by the way, guys? So this is what we have to remember. This is also called as 1u is equals to 1.67 into 10 to the power 1.66 into 10 to the 1.67 we may write. Even I forgot how much was it. Minus 24 gram. Now you learn it. This called as atomic mass unit, AMU, or you may also call it unified mass, U. So that is what we also can write it. So how, and this is also called as avogram. This 1u itself is also called as avogram. So it's single thing and which has multiple names. Avogram. So we have got it. Now we have relative atomic mass. Initially we studied atomic mass, which is nothing but the mass of an atom. Now we have come to relative atomic mass. Okay, try to learn this part, that this is something which is huge, which has huge importance in our complete mole concept. Those who can understand the concept of writing the atomic mass, relative atomic mass, molecular mass, molar mass, gram atomic mass, so many things are there. If you know about it, this entire mole concept will become highly easy for you. So we have relative atomic mass, also called as RAM. So RAM is actually a unitless quantity. How? Because take this example. Relative atomic mass of hydrogen. So guys, take this idea. Let us suppose my name is Sanjay Arya and my mass is 50 kg. Let's taking the example. And I have 4 people in my gang by the name of, let us suppose, A, B, C and D, with their masses of 50, 100, 115, 200 respectively. So let us suppose A has a mass of 50, B has a mass of 100 kg, C has a mass of 150 kg, and D has a mass of 200 kg. I am expecting my mass as 50 kg, let's say, and now onwards my mass has been taken as a reference mass. It's reference to everyone, and I have been called as 1 U mass, 1 unit mass. I have been called as 1 unit mass equals to 50 kg. So according to me, like taking me as a reference, what will be the masses of the other 4, A, B, C and D? So their masses will become 1 unit, 2 unit, 3 unit, 4 unit respectively. Exactly like that we have to implement this part, that relative to mass of hydrogen will be equals to atomic mass of hydrogen divided by the unified mass, which is 1/12 of 1/12 mass of C12 atom. So this is already we have gone through 1.673 10 to the power minus 24 gram, and this also we have identified 1.67 into 10 to the power minus 24 gram, and it nearly comes up as, guys, 1.008. And what should be the unit, by the way? There should be no unit. If I have put it like 1.008, it's no unit because this is gram, everything is cancelled out. But using this data, what you can identify is, if you cross multiply this part, guys, if you cross multiply this part, you will be getting that atomic mass of hydrogen will become, this is equals to relative atomic mass, which is 1.008 into 1/12 mass of carbon is called as U. So now onwards, this U will becomes a unit to define atomic mass. Check it out. So very small amount in magnitude can be represented in the terms of U, where U is called as the unified mass, or AMU, atomic mass unit, or there are multiple names of this. So now I will move forward. We have another term. Okay, now before going to next part, I must explain the relative atomic mass and atomic masses of all the species. So this is your homework. This is your element. This is its symbol. This is the atomic number, and this is the atomic mass. Now believe me, we will be writing the atomic masses in the terms of U only. So let us take the first element. So atomic number 1, 2, 3, 4, 5, 6, 7 and 8. So element is hydrogen. Symbol is H. Mass is 1U. 1.008, 1U, 1 is fine. We have helium. Helium has an atomic mass of 2. Atomic mass will be 4U. Atomic number is 2. Lithium. Li. Atomic number is 3. Mass is 7U. Beryllium. Beryllium has a mass of symbol Fb. Number 4, 9U. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen. We'll write it there only, oxygen. Okay. So symbols are boron B, carbon C, nitrogen N. Boron has a 10U, carbon 12U, nitrogen 14U. Similarly, others can also be written down as nitrogen, oxygen, aluminium, silicon, phosphorus, sulfur, chlorine, argon, and we all know their atomic numbers. Okay, thank you guys, thank you. Oxygen, symbol is O, atomic number is 8, mass is 16U. So now atomic masses onwards will be written down with the unit of U. We all know the value of U. Anywhere you want to find out the mass in gram, you put the value of U, that is 1.67 10 to the minus 24 gram. You can get the value in grams. Aluminium is Al, silicon Si, phosphorus P, sulfur S, chlorine Cl, and we have argon is Ar. Masses, we talk about their masses. Aluminium, okay, has atomic number of 13, 14, 15, 16, 17 and 18. Masses 16U, 27U, 28U, 31U, 32U, we have 35.5U, and then we have, let's say, 38 or 40U. So now with this mass, we got one mass in very weird way in decimal. So first of all, you need to write down homework. Homework is pretty easy, that learn atomic symbol, number and masses of all elements from atomic number 1 to atomic number 30. So till 1 to from 1 to 30 you have to learn all the atomic number, symbol, number, mass, everything. And then also for you need to do the same exercise for some of the important elements also, which are not given here, such as bromine, iodine, we have uranium, we have heavy metal such as lead, silver. This is also we should remember. And rest everything will be covered up to your Z1 to 30. This is your homework. Now we should move forward. That is your homework. Now the confusion was that how come we are taking the mass of chlorine as 35.5 and rest everyone came a full complete number, but average mass is basically there taken. So we need to know what is an isotope, how we are gonna to define an isotope. So guys, first of all, know about isotope. Which are atoms of the same element having same atomic number. Of course, one element has anything which belongs to same atomic number will be having same element will be having same atomic number, but different atomic masses. So what we can take into example, see, (1H1). This is called as protium, deuterium, tritium. So guys, you can see the atomic masses are 1, 2 and 3U respectively. So that is the perfect example I gave you. So for these kind of what we say, these kind of element, how do we find out the average atomic mass? Very simply we can do that. Arm will be equals to the atomic mass of first into its percentage abundance plus atomic mass of 2 into its percentage abundance, atomic mass of 3 into its percentage abundance, this whole divided by complete percentages. Guys, on solving you will get, we can write this whole part as summation of I is equals to 1 to n a into I into x of I. What is not x? This is percentage of I, and this whole divided by the sum of all percentages will be equals to 100. This is called as average atomic mass. This is called as average atomic mass. So let's try one question. An element X has two isotopes, X56 and X58. Natural abundance of lighter means 56, one is 20 and the another one will be 80. Average mass will be what? So guys, we will simply do arm of X is equals to mass into percentage abundance. Lighter one is 56, percentage is 20%, plus another one is 58 into 80%, because 100 minus 20 is 80. Two isotopes are there, divided by 100. Now solve it and you will get your answer. So this will become 56 into 1 by 5, plus individually I am dividing it, 58 into 4 by 5. Solve it. I guess your answer will come up as 57.6 gram. Not grams, they are U. Unified mass. Similarly, we have another question. So guys, in these kind of question, that chlorine exists into two isotopic form, Cl35 and Cl37. So I am giving you an idea and we'll solve these questions in my practice session. I am giving you this question as a homework to all of you. You need to do is that assume that Cl35, Cl chlorine with a molar mass of 35. Let this chlorine be X%. So the remaining Cl with 37 mass will become what? 100 minus X%. Now since all things are given to you, now just solve it and use the formula that AAM of chlorine will be equals to 35x plus 37 into 100 minus x divided by 100. This has been given to you. How much is it? 35.5. Solve it and get the value of x. Then we have come to gram atomic mass. Gram atomic mass. JAM. So guys, this is no different. This is very easy to write. Take this example. Let's say if we are talking about hydrogen. So hydrogen has an atomic mass of how much? 1.008 U. So gram atomic mass will become what? 1.008 gram. It's that simple, guys. Whatever the example coming up in mind, you can pick it. Let's say I'm talking about chlorine. Right now only I talked about the average atomic mass is equals to 35.5 U, but the gram atomic mass will become what? 35.5 gram. It's that simple. So we are just about to write the mass in gram, not even converting the values. Just simply write it in terms of G. Write in the terms of G. So now if somebody asks you that how many number of atoms are there in the atomic gram atomic mass of anything. So guys, we all know since gram atomic mass of carbon is how much? 12 gram. And atomic mass of carbon is how much? We say 12 U. So that's why number of carbon atom. We know that which quantity is bigger. Undoubtedly in grams it is bigger because U means just 1.678 minus 24 gram, which is very small. So number of carbon atoms in its gram atomic mass will be equals to. The equation becomes 12 gram divided by 12 U. So how much is 12 gram? Simply 12 gram, but U we know the value 12 upon 1.67. No, not divided by, it's multiplied by. 1.67 10 to the power minus 24 grams. Now gram will be cancelled, 12 will be cancelled. This value 1 by 1.67 10 to the power minus 24 comes up as 6.63 to 10 to the power positive 23. This is some good number. This number is actually a constant. Yeah, hello bachcho, hello guys. So now let me take you to another such example. Let's say if I perform the same experiment with hydrogen. Let's say I perform the same experiment with hydrogen. We know that its gram atomic mass will be gram atomic mass 1.008 gram and atomic mass is 1 U. So number of hydrogen atoms in its gram atomic mass will be equals to how many number of hydrogen atoms are there in its gram atomic mass? That will be 1 gram divided by 1 U. 1 gram divided by 1 into 1.67 10 to the power minus 24 gram. Gram will be cancelled, only a number will come, that is 6.022. Here also the same number came, 6.63 nahi yaar. .022. This is 6.022 and 23. So what we are observing, guys, that this number is a constant. It's coming, every gram atomic mass is giving us the same number of atoms in it. So now starts mole, a counting unit, because that number is actually means something, and I have to give you an idea of mole first of all before going to that number. Before going to that number, we all must take an idea what is the meaning of a mole. So mole is a counting unit. Mole is what? A counting unit. But why are we taking counting unit? Because for all microscopic particles which can't be seen, which are not visible to us. So like take this example, collection of 12 is called as 1 dozen. Collection of 2 people is called as a couple. In the similar way, a collection of 6.022 10 to the power 23 particles is called as 1 mole, and it is represented by Na. So guys, microscopic particles, it can only be used for microscopic particles. Particles which are very small, that can't be seen by naked eyes, called microscopic particles. Its example could be atom, molecule, ion, electron, proton, neutron. It's like that. So that is what a counting unit mole means. So guys, did you observe that the collection of 6.022 10 to the power 23 is called as 1 mole, That means gram atomic mass is also equals to 1 mole, because gram atomic mass had exactly the same number of particles that was available in 1 mole of any substance, 6.02 10 to the power 23. This alien looking like a guy named as Amedeo Avogadro actually brought this concept, which is 1 mole, and which is very huge number. Guys, it has been said that a 1 single mole of a compound or 1 single mole of a substance contain this much number of entities, which is 6.0 10 to 23. It's too big that even if you put this dot 6.022 10 to the power 23 times, it can cover whole earth surface. This thing will cover what? Earth's whole surface area available. This big, this number is 6.0 to 23. So that's why we are not comparing that number with anything. That's why it is defined only for microscopic object, not for the macroscopic. Now coming to the molar mass. Molar mass means mass of 1 mole of any substance. Mass of 1 mole of any substance. And periodic table masses with a unit of gram per mole becomes their molar mass. So whatever the atomic mass you people have learned till now, if you put the unit as gram per mole, it will become its molar mass, because the number of particles in it are gonna to be 6.02 10 to the power 23, which is defined as the collection of 1 mole. So very important. The units are gram per mole, not just gram, because if you are putting just gram, it will become gram atomic mass. And then we have mathematically molar mass and gram atomic mass. These all are same, but units are different. I don't know till where you people got understood the whole topic or not, but I am gonna to give you the perfect example which will help you to sort out everything. Now take this example, hydrogen. What is the atomic symbol, atomic mass of hydrogen, everyone? Hydrogen is 1.008 U. Whenever I write atomic mass, I will use the term U. Relative atomic mass is something which is unitless, because it is calculated with respect to the 1/12 mass of carbon atom, which is again U. It is equals to U only. Gram atomic mass will be 1.008 gram, and molar mass will become 1.008 gram per mole. Carbon mass 12 U. Relative mass 12, gram 12 gram, molar 12 gram per mole. Oxygen 16 U, 16 gram as gram atomic mass, molar mass will become 16 gram per mole. So guys, we all need to know how do we write the molar mass, gram atomic mass, atomic mass, and relative atomic mass. Sodium has 23 U. 23 is the relative mass, 23 gram becomes the gram atomic mass, 23 gram per mole becomes the molar mass. Check it out. Now this part, this question, this part of the question will complete your, will be definitely cover your all the doubts existing right now in your mind. Now we have how many calcium atoms in 0.250 moles of calcium are there? How many calcium atoms are there? See, so guys, we all know that 1 mole of calcium contains how many? 6.022 10 to the power 23 atoms. So 0.250 moles will contain how many? 6.022 into 10 to the power 23 multiplied by 0.25, which is actually 1 by 5, 1 by 4. 6.022 into 1 by 4 into 10 to the power 23. So Na by 4, because 6.022 into 23 can also be written as Avogadro number Na. So now next is calculate the number of moles in this much number of atoms. So you can do it by your own. Now homework, and in my practice session I'll explain all the questions to you. Find the mass of one helium atom in grams. Very important question. Again another homework for you. These all question I'll solve in my practice session, but I can give you an idea that always remember 1 U is equals to 1.67 10 to the power minus 24 gram, and atomic mass of helium is how much, everyone? 4 U. So just put the value of U as this and you will get your answer in gram. Then we have come to molecule. You all know what is the meaning of a molecule. What is a molecule? Molecule is a constituent particle of a compound which is formed by the chemical combination of atoms in a fixed number of their fixed mass ratio. So take this idea: hydrogen molecular formula will be H2, hydrogen chloride has HCl, water is H2O, methane is CH4, ammonia is NH3. So these are the molecular formulas of all the molecules which are mentioned here. Now how can you calculate the molecular mass? So sir, simply sum of the atomic masses of all the atoms present in a molecule. So how many atoms are there? 2. So 2 multiplied by 1.008 U, it will give you what? 2.016 unit will become U only. So molecular mass will also be mentioned in the terms of U. For HCl, 1 is 1 U plus Cl will be 35.5 U. 36.5 U is the answer. H2O, 2 times of 1 plus 1 times of 16, 18 U. Methane, 1 times of 12, 4 times of 1, 16 U. Ammonia, 1 times of 17, 3 times of 1, 17 U. So that's how you can find the masses respectively, molecular masses, right? Exactly like atomic mass, we have now molecular mass. Now again the gram molecular mass will be the same only. Let us take this example of ammonia. What is its atomic mass? Oh sorry, molar mass will be what? Sorry yaar, molecular mass. Molecular mass of ammonia is what? 17 U. Then what will be its gram molecular mass? 17 gram. It's that simple. So guys, if you find out the number of atoms, calculate the number of water molecules in its gram molecular mass, you will find that in GMM the same number of molecules will come. Like if we talk about water, what is its molecular mass? U. And what it is gram molecular mass? Gram molar mass 18 gram per mole. So using not per mole, just 18 gram. So find out the number of water molecules. In its gram molecular mass. Bigger one 18 gram, smaller one 18 U. 18 will be cancelled. 1 gram by 1 U comes up as 1 gram by 1 U. 1 is 1.67. 10 to the power minus 24 gram comes up as 6.022. 10 to the power 23 is equals to 1 mole of particles, or 1 mole. So guys, we ultimately have come to this conclusion that whatever be the molecule we are now talking about, whatever the molecule, if you find out its gram molar mass and you find out the number of molecules present inside it, it will always be coming up as 6.022 10 to the power 23, which is a constant and called as Avogadro number. So if this is a constant and it is equals to 1 mole, what we can define is this, that anytime you are given up with a molecule, hydrogen, we know the molecular formula H2, hydrogen chloride HCl, water H2O, with all these molecules we can find out their molecular mass. It will become 2U, 36.5U, 18U, 16U, 17U. Then relative, simply 2 without any unit. Gram, if you put there gram, then it will become gram molar mass, 2 gram, 36.5 gram, 18 gram, 16 gram, 17 gram. Molar mass, what is the molar mass? 2 gram per mole, simply put per mole. 36.5 gram per mole, 18 gram per mole, simply just put gram per mole. 16 gram per mole, 17 gram per mole. Now you all know how do you calculate out their molar masses. You got to find out the molecular mass by adding the atomic masses of all individual entities and individual atoms, and that simply give them a unit of gram per mole. So we already have gone through the crystalline structure. We will simply write the formula unit mass. Take an example, everyone. Just sum all the ions or the atoms present in it. Just like NaCl will be having 23 plus 35.5 is equals to 58.5 U. We have magnesium chloride. We have 24 plus 2 times of 35.5, 71 plus this 95 U, and so on. You can find out whatever you want. Now gram formula mass will again just put this gram, you will get the gram formula mass. Like NaCl is there, if you are finding out the formula unit mass, it will become 58.5 U, we just have calculated. But if you find out GFM, it will become 58.5 gram. Take this example, MgCl2. What is the formula mass? 95 U. Gram formula mass 95 gram. Number of formula unit, if you don't find out, exactly the same you will find out, that number of NaCl units will be gram formula mass divided by formula unit mass. Gram formula mass is how much? 58.5 gram divided by 58.5 U. This will be cancelled out. It will become 1 gram by 1 U, and we all know 1 U is equals to 1 gram upon 1.67 10 to the power minus 24 gram. This will become 6.022 10 to the power 23. Now again we have got the same number, which is equals to the 1 mole. So that's how we can conclude that sodium chloride has a formula unit NaCl. Its formula mass will be 58.5 U. Relative formula mass will be simply 58.5, simply 58.5. gram formula mass will be 58.5 gram and molar mass will be 58.5 gram per mole. How easy. Calcium carbonate CaCO3 has a formula mass of 100 U, relative 100, gram 100 gram, and molar 100 gram per mole. Similarly, magnesium sulfate, we have MgSO4. So you people do it by your own. Homework and homework. You do it by your own. Don't let me do all the questions for you. So guys, that is a simple definitions of different type of masses, atomic, molecular, and so many things. So guys, this is something which is very important, that whenever you are written with the gram or it will equals to molar mass only. If somewhere it is written that gram atomic mass, it is equals to molar mass. If somewhere it is equals to gram molecular mass, also equals to molar mass. If we have gram ionic mass, we too have equals to molar mass. Magnitude wise they are same, and the similar way we have gram formula, not just unit wise also they are same, but just only one mole we write with molar mass, and rest everything is same. Gram formula mass is equals to molar mass. So guys, simply do one thing. We remove this mass, then it will give you the conclusion that whenever it is written as gram atom, it means mole. Gram molecule equals to mole. Gram ion is equals to 1 mole, and gram formula is also equals to mole. Just write it down, everyone. Please write it down. Please write it down. Hopefully you all have come across what I'm telling you. So guys, this is how modern presentation of mole is written down and sometimes given in the question. So modern days. So nowadays guys, we do not write it moles and all. Somewhere you can find written gram atom, gram molecule, gram ion. S block please, we'll come to S block, no problem. So try this question everyone. How much 1 gram atom of calcium weigh? Tell me how much 1 gram atom of calcium weigh? 1 gram atom of calcium weighs how much? See, since this is 1 gram atom, gram plus atom means 1 mole of calcium. 1 mole of calcium stands for molar mass of calcium. Will weigh how much? Molar mass. And molar mass is how much? 14 gram per mole. So 14 gram is the correct answer. C. Then we have another important topic called as calculation of the number of moles. So number of moles are represented using this formula N, using this symbol N, and there are 3 possibilities of calculation of the number of moles. So first of all, let us define what is the meaning of number of moles. Moles means the amount which contains as many as number of particles present in the 12 gram of carbon atom, which means that simply we can write that a collection of collection of 6.022 10 to the power 23 particles is called as 1 mole. So guys, number of particles, if number of particles are given, there is a simplest formula. You can apply this unitary method also, that since 6.022 10 to the power 23 or Na number of particles contain 1 mole, then this n number of particles will be containing how many moles? 1 upon Na into n. So n upon Na becomes the formula very easily. So you can find out the formula that number of moles will be equals to given number of particles divided by Avogadro number. Now this particle could be atoms for element, molecules for compound, and formula units for ionic compound. One simple question is here. Calculate the number of moles of oxygen gas containing 2.4 10 to the power 22 molecules. So we know the formula of number of moles of oxygen will be equals to given number of particles divided by Avogadro. Particles are 2.4 10 to the power 22. This is 6.022 10 to the power 23. 23, 22, it will become 10 to the power 1. This is 0.4 into 10 to the power minus 1. 0.04 moles is the correct answer. So 0.04 is the correct answer. 0.04. 0.04. This answer it is given good. Option was not correct. Answer is given correct. Anyways, Next, second case, when you are given with the mass of substance. So guys, simply unitary method can be applied, that if m is the mass, which is molar mass, number of mole will be 1. If w is the mass, then 1 by m into w, that is w by m. So simply the formula becomes number of moles is equals to given mass upon molar mass. Very simple. Let's try one question here. We have a question here. Calculate the number of moles of water present in 72 gram. We all know that molar mass of H2O is equals to 18 gram per mole. We already have come across this. Given mass W of H2O is 72 gram. Number of moles of water will be given mass upon molar mass. So if 72 by 18, this will be gram. This will be gram per mole. So gram will cancel. Mole will go up. It will become 4 mole. Correct answer D. See how easy is this. Very good, Advait Krishna. Advait Krishna, you are going good. Very good. Then we have the third part and third way of calculating the number of moles. Guys, if you remember in the initial, when I was teaching you about inert gas equation and PV equals to nRT, along with that I was teaching you about this STP, which is standard temperature and pressure. Under that condition, standard condition, we know that molar volume of a gas, which is an ideal gas, occupies 22.4 liter. So we know that 1 mole of any gas contains 22.4 liter. That means at STP, since 22.4 liter volume is contained by 1 mole, contains 1 mole. So that's why V volume will be contained by how many number of moles? 1 by 22.4 into V, that is V by 22.4. So simply you can find out what? Number of moles is equals to volume upon 22.4. See, this is liter per mole. This should be in liter. So liter will be cancelled out, mole will go up. V by 22.4 is the formula. But if you are taking this thing into milliliter, then it will become V in milliliter divided by 22,400. I just multiplied this equation by 1000 in order to convert it into milliliter. Now this is milliliter mole inverse. Clear everyone? This is how we calculate the number of moles for in terms of volume. Now there is a question. Now you please try this question and let me know the correct answer. Try it by your own, everyone. Sir, is it not 11.2? Oh my God. I think you are correct, Advait. Anyways, let's see. We have 0.5 moles with so guys, we need to calculate the volume. We all know that number of moles is equals to volume of in liter divided by, okay, if we talk about the milliliter, I don't know how come there is no correct answer here. No correct option is given. No problem, guys. We'll learn quickly all of these formula. And for this, I have a Y map for all of you. I call this technique as Y map. So I must write it with white only. See guys, this is given a mass in grams, and this is given number of particles, capital N. This is given with volume in liter at the rate STP, standard temperature and pressure. So volume if given, and you have to find out the number of moles. This is N number of moles. So volume in liter need to be divided by 22.4 and you will get the value of moles. But if from moles you have to find out the volume, then number of moles have to be multiplied by 22.4 and then in liters you will get what? Volume. Then similarly, let's suppose if mass is given to us and we have to find out the number of moles. So in order to number of moles, you will do given mass upon molar mass. You will apply M is the molar mass. And if moles are given to you and you need to find out the weight, then number of moles multiplied by molar mass will be applied. This formula will be applied, right? Any problem? Do let me know. Correct. Similarly, in third way, if number of particles are given and you need to find out the number of moles, just simply do N divided by Na. And if you go in reverse direction from number of moles to number of particles, you have to find out N will be multiplied by N. This is called as a Y map. You call it a Y map. It's looking like a fidget spinner also. So this is way of learning all the three formula together. Calculate the volume of 8 gram of SO3 at STP. Now it's very easy. If you have to go to atoms, like there are three parameters, number of particle, mass and volume. If any one of the parameter has to go to any other parameter, the way only goes through the number of moles. So let's say this is an example. Weight has to be converted into volume at STP. So first of all, find out the number of moles. So guys, you all must know how to calculate out the molar mass of SO3, and once the molar masses of these frequently used compound are known, you must take these in your mind every time. Take this example, SO3. SO3 sulfur has a mass of 32 plus 3 times of 16. This total comes up as 80 gram per mole. 80 gram per mole. Now you put it over here. Number of moles will be given mass upon molar mass. Moles are 0.1 moles. Now find out what? Volume at STP. So volume of SO3 gas will be at STP. Number of moles multiplied by 22.4. I told you that time. Liters will be the answer. 0.1 into 22.4 is equals to 2.24 liter. 2.24 liter is the correct answer. So 2.24 liter can also be written as 2240 milliliter. So believe me everyone, we will solve so many questions. As of now, I would expect you people to solve some questions by your own, and later on, right after that, in my practice session, I'll help you to explain others. So this is homework. This is homework. This is homework. I have already provided you the answers, so you can compare. Homework. होमवर्क करे यार, let me directly reach to the next topic. So your next topic is stoichiometry. Our next topic is what? Stoichiometry. So what is the meaning of stoichiometry, guys? Stoichiometry means two things we are talking about. One of them is stoichion. These two are Greek letter which mean stoichion means talking of elements and metric means doing the calculations. So if we are doing the calculation of elements, we call it stoichiometry. And always remember that all these stoichiometry calculations are applicable for balanced chemical reactions only. So if you people do not know how to balance the reaction, know it first of all, then only you will be able to move forward to the stoichiometry calculation. First of all, I'll explain what is the meaning of this stoichiometry. It means that for a balanced chemical equation, anyways, first of all, let us know what is the balanced chemical equation. A balanced chemical equation is one that follows law of conservation of mass, means mass left hand side right hand side should be equal. Also principles of atom conservation, that means number of total atoms in left hand side and right hand side must be equal. Take an example that number of moles, number of atoms of nitrogen. Nitrogen is how many in left hand side? 2. Nitrogens in how many in right hand side? 2. Hydrogens are how many in left hand side? 6. Hydrogens are how many in right hand side? 6. So this is what the meaning of atom conservation is. We have another important term called as mole-mole interpretation. Mole-mole interpretation means that for any balanced chemical equation, let's say N2 plus 3H2 2NH3. Guys, believe me, this is the most important part which we are gonna to start with. You people already know about moles, you already know how to calculate moles, you already know so many things about the moles. Now we have an important part to attempt called as interpretation. Like, what is the significance of writing a balanced chemical equation? You always must have a balanced chemical equation, else you cannot apply the calculations, your answer will come up wrong. It should be a balanced chemical equation. Balanced chemical equation, whatever it is written here, read it out. If something is not there, that means 1 is there. It is 3, it is 2. That it will always maintain 1:3:2. So what does it mean? That if, let us suppose 2 moles of nitrogen are combining with 6 moles of hydrogen, then 4 moles of ammonia will be formed. If, let us suppose n moles of nitrogen combines with 3n moles of hydrogen, then 2n moles of ammonia will be formed. This is the meaning of interpretation. That what is the significance of a balanced chemical equation is called as the interpretation of mole and mole. Mole-mole interpretation means the significance of a balanced chemical equation. Now, what is mole-mole analysis? This is another very easy and very important mathematical equation that comes in our use. So everyone do remember this part, that for this given chemical reaction, which is already a balanced chemical equation, if it is not balanced, then we cannot do any calculation. The number of moles of A completely reacted upon its stoichiometry is equals to number of moles of B reacted with its stoichiometry, number of moles of C produced upon its stoichiometry, and number of moles of D produced upon its stoichiometry D. What is the meaning of that? It's simply, what I can say, unitary method. Take this example again. AA, BB, Cc. So guys, we all know, let's say Na moles of A are reacting completely, this is what interpretation say, with Nb moles of B. If it is reacting with Nb moles of B, then what is the relationship between these two? So simply see, since small a moles, check it out everyone, small a moles of A combines with small b mole of B. So that's why 1 mole of A combines with B by small a moles of B. So that's why Na moles of A will combine with how many? So this will become B by A into Na is equals to number of moles of B is also Nb. I recently wrote it there, small n was there actually. So using this equation, what you can derive, guys? Check it out. Na by A is equals to Nb by B. Hence proved. This is how we have proved it. It's just a unitary method, nothing more than that. Nothing more than that. So guys, this is how we use the information in order to find out the number of moles. Let us suppose one question is given over here on the same mole analysis or mole interpretation. So we are given up with that mass of carbon dioxide that will be found when 1.2 gram of carbon it is undergoing a complete combustion. That means 100% combustion is happening, and oxygen will be given in excess, so we don't need to consider oxygen. Yeah. First of all, write down the complete equation. C plus O2 gives CO2. So now, first of all, we have time is equals to 0. This is given to us 1.2. Not required to write down the time and all. We know that 1.2 gram is given. We need to find out the number of mole first of all. So how many moles will be there? This is 12 gram per mole. So this will give you what? 0.1 mole. So there is no need of applying mole analysis. We can directly see that 1 mole of carbon gives 1 mole of CO2. So 0.1 mole will give you 0.1 mole of CO2. Now mass has been asked to us. The mass of CO2 will be how much? Number of moles into molar mass. Number of moles are how many? 0.1. Molar mass is how much? 44. The answer is 4.4 gram. 4.4 gram is correct answer. Then next is, this is some homework for you people. Don't you think that I will not solve these problems? I will solve these problems in my practice session. Since this is a theory session, I will complete all the theory related part. Then I'll come to the rest of the part. This is another homework for you people. This is another homework. And now let me take you directly to percentage purity. The next topic is called as percentage purity. As I told you that we will cover every single part of this topic. We have percentage purity. Guys, this is again very easy question. This is a very easy concept, that always remember that only a pure substance participates in the, only a pure substance participates in the chemical reaction. So how we can find out the percentage purity? Percentage purity is equals to mass of reactant, reacted actually, divided by mass of reactant total, or like impure means complete, into 100. This represents what? Percentage purity of a sample. That only pure part of particular substance is allowed to react. So rest remaining impure part will do what? Remain unreacted, no other than that. Let us try one question and then I'll take you to another similar concept. The right option for CO2, the mass of CO2 produced by 20% and the pure limestone, 20% pure limestone. So guys, see, W of impure is how much? 20 gram. So W pure will be equals to what? 20% of 20 gram. So 20 by 100 into 20, it is 4 gram only. So how much CO2 will be formed? So write down CaCO3 on reaction, on heating, produces CO plus CO2. We all must write a balanced chemical equation, otherwise we will not be able to apply the stoichiometry. So since this is 4 gram, 4 upon 100 gram per mole is the molar mass. So number of moles are 0.04 moles. So this will also be 0.04 moles. Because 1 mole produces 1 mole, 0.04 will produce 0.04 mole. So mass of CO2 produced will be how much? For given number of moles into molar mass. Moles are how many? 0.04 into molar mass is 44 multiplied by 4. So 1.76 gram is the correct answer. Now using the same technique you can also find out some more relevant questions. Using the same technique you can find out. This is something that you will do by your own. This is a homework which is a very good question by the way, and I have tried it by my own actually. but we'll explain you this question. Don't worry guys, I'll pick all of these questions along with very like PYQs of all 2020 till 2024. I'll pick all the mains and advanced PYQ, and then I'll come up over here. We'll take you some 3 or 4 kind of hours of session, and we'll practice all the questions which are we are right now solving the concept upon. So now we have one other very important concern, very important topic, everyone, for all of us. This is called as limiting. How many I come there? Limiting reagent. We have another important term called as limiting reagent. So what does it come in your mind when you hear this term limiting reagent? Seems like something will get finished, right? Isn't it? Limiting means something will get finished. So who will get finished and when and why and how? We'll let you know. I'll let you know. So we have 10 cell phones here, everyone. I would expect answer from every one of you. We have 10 cell phones. We have 5 Nippo batteries. Every single cell phone requires one single battery to operate. So how many cell phone will work? If every single phone requires a single battery, then how many number of cell phones will work? So guys, let us try this one more time. Every single battery can make one phone work. There are 5 batteries, there are 10 cell phone, only 5 will work at once. So I guess which is playing an important role? It's battery, not a mobile phone, because some of the mobile phones are remaining without working, but batteries are all utilized. So now let us start this concept of limiting reagent. So guys, what will happen in some reactions? One of the component of the reactant will be given in excess quantity. The another component of the reaction will be given in the limiting quantity. So we got to basically differentiate between these two, that which will decide the maximum amount of product form, that is none other than the limiting reagent. But also limiting reagent will help us to find out the exact amount of product formed, exact amount of reactant utilized, exact amount of unutilized excess reagent left upon. So this is all about the limiting reagent. Now we'll come to limiting reagent and we'll start some problem solving upon it. We have one question, everyone, over here. We have one carbon on reaction with oxygen produces CO2, and in this equation we have 30 grams of carbon, 32 grams of oxygen, and we'll find out how much CO2 is formed. So this should be your balanced chemical equation. If it is not balanced, you cannot apply stoichiometry, you cannot apply limiting reagent, you cannot apply anything. In mole concept, you need to balance everything. Divided by 12 gram per mole divided by 32 gram per mole. How many numbers are coming? 2.5 moles, and this is 1 mole. So guys, just simply observe this part. Since we do not have any stoichiometry here, it's very easy to communicate and to declare which one of them will be the limiting reagent. One carbon reacts with one oxygen molecule, or 1 mole of carbon reacts with 1 mole of oxygen. So 1 mole is reacting with 2.5 moles since it is more. So that means this has become what? Excess reagent. This has become what? Limiting reagent. So now everything will be decided by limiting reagent only. Now you can simply solve this question. Mass of CO2 you need to find out. Simply find out the number of moles of CO2 divided by the stoichiometry will be 1, will also be equals to the number of moles of limiting reagent. Who is limiting reagent? Oxygen upon 1. So you will be getting the number of moles of CO2 over here will be how much? 1 mole. So the mass of CO2 formed will be how much? 1 into 44 gram per mole. So 44 gram is the correct answer. That's how we do the calculations. That's the concept of limiting agent. But what happens if we are getting this kind of situation where we are having some complicated stoichiometry, where we are not very easily predicting, and which can become a limiting reagent? Then what you need to do, simply do my technique, number of moles of A divided by stoichiometry A and number of moles of B divided by stoichiometry B. Just compare them. Let's suppose this is coming in higher magnitude, then this will become excess reagent, this will become limiting reagent, and then apply all calculations with respect to limiting reagent only. So that is how we do. This is the shortcut part. Don't worry everyone, this is just a theoretical part, but when I'll come to a question, I'll explain what is the application of this formula and how am I using it. 4 hours gone, feeling exhausted, sorry. So guys, try this question and let me know which one of them will be LR and how, and the option will be given in this comments only. You give your options in comment. Yeah, buddy. So we have been given up with two different things. One of them is nitrogen, the another one is hydrogen, and they are producing ammonia. But we have to make one thing very clearly, that the reaction should be balanced chemical equation. Reaction should be balanced chemical equation. Okay, I'll try. So given is, what is given to us by the way, 28 gram divided by molar mass of nitrogen n plus n, 28 gram per mole. One nitrogen is 14, two nitrogen will be 22.14 plus 14 plus 14, 28. Number of moles will be, given mass is 8 gram, molar mass of H2 we have to take. Molar means 1 moles ka mass. You are not supposed to take 3 into 2, no. Just simply 1 mole is H2, 2 gram per mole. So this will be 1 mole and this will be 4 mole. Now no doubt this is coming more, but we have to cross check to find LR. What we do to find limiting reagent, there are two processes we can find out limiting reagent. One is 1 mole of nitrogen combines with 3 mole. So one will combine with 3 mole and this is 4 mole. This is in excess. Another way you can do without doing the unitary method, just apply mole analysis wala method, 1/1 versus 4/3. Again this is more, this will become excess reagent, this will become limiting reagent. Now what is the mass left of nitrogen? How do you find out? So number of moles of nitrogen, which is like limiting reagent, no? Nitrogen is limiting, yeah. So number of moles of nitrogen upon its stoichiometry is equals to number of moles of hydrogen reacted divided by its stoichiometry is 3, N2 plus 3H2. So number of moles of nitrogen reacted will be 3 moles, because this is actually given to you 1 mole. So number of moles of hydrogen unreacted will be how much? 4 by 3 minus 3 moles, 1 by 3 moles. This is not 1 by 3. What do you think? 1 by 3 only. No yaar, this is 1 actually. Used are 3 mole. Okay, sorry. So 4 minus 3 is equals to 1 mole is the excess. So mass of hydrogen unreacted will be moles into molar mass. Moles are how many? 1 mole. Molar mass is 2 gram per mole. Come up as 2 moles only, 2 grams. That's how we find it. Then we have number of nitrogen, hydrogen, everything is done. Mass of ammonia will be how much? So mass of ammonia divided by we have stoichiometry 2 will be equals to number of moles of nitrogen by 1. So number of moles of ammonia comes up as 2 moles. So 2 moles means mass of ammonia formed will be how much? Moles into molar mass, which is 17 gram per mole. This comes up as 34 grams. So guys, how easily you can find all the possibilities of this question by just simply knowing one limiting reagent. You can find out everything. Now we have some set of questions here that is expectedly will be done by your end. You got to do this is as homework. We have plenty of questions on this topic. Try them by your own and stay confident. Some of them are having answers as well. And I will directly take you to another important question, another important concept called as principle of atom conservation. And usually we use this technique of principle of atom conservation, or we use this funda where we are given up with the successive reactions, like A is reacting with B producing C, C reacts with D producing E, and E is going this, where one of the atom will be conserved throughout the reaction. So I must tell you that in an isolated system, they remain an element remains conserved throughout the system. Let us take directly the example. That was a statement, and now we'll apply to that. So apply principle of atom conservation on sodium. Without looking at this question, I can do this. Now let me read it. NaOH is formed according to this reaction. To make 4 gram of NaOH, Na required is how much? So guys, Na is conserved throughout the reaction. So first of all, you must know that number of moles of NaOH will be equals to the number of moles of Na. How? Because sir, in NaOH only one Na is there. So number of moles of NaOH will be how much? 4 gram divided by 40 gram per mole is equals to number of moles of Na. This is equals to number of moles of Na comes up how many? 0.1 mole. 0.1 mole. So what we'll do? Mass of sodium we need. Very simple, moles into molar mass. Moles are 0.1. Molar mass of sodium is 23 gram per mole. This is mole. Mole into mole will be cancelled out. Gram will be the answer. 2.3 gram is the correct answer. Now pick up the correct answer. D. C. Then guys, we have another important topic called as percentage yield. Just like percentage purity, we have percentage yield also. So how is percentage yield calculated? So let us suppose we have a reaction going on, but only few percentage of the reactants are converted into product because of so and so reason. So such type of reactions are called as like incompleted reactions, and 100% yield is not possible, no doubt. So what we'll do, try percentage yield will be equals to, so I'll try the term into two terms. One of them is into the terms of product. So we'll do number of moles of product, maximum expected or theoretically, no, product actual oblique practical, actual oblique practical divided by the number of moles of, so this could be number of moles also, this could be mass also, or like let's say this is mass also, we can take whatever you can take, because this is the ratio, it will be cut out. Okay, it will be eliminated. If you even put the molar mass here, it will be eliminated out. Or mass of the product theoretical oblique expected into 100. This is the percentage yield. One of the formulas is. Or we can say in terms of reactant, W of reactant reacted upon W of reactants taken initially, that's also percentage yield, because we know that 100% is not reacting, and that's why 100% yield is not obtaining, 100% product will not be produced. This happens in the case of percentage yield. Now let us try one question. The mathematical expression of percentage yield is already completed over here. Same thing. We'll directly reach to one question. We have an actual yield of 29.3 gram of the product and the theoretical yield is 35. Oh, this is so very easy. So percentage yield, which is W of product, actual means actually how much are you getting, upon W of the product expected into 100. Produced are 29.3, definitely will be lesser than the produced expected. Expectations were always high. Just like we want to score 100 percentile in our marks, which is our expectation, we will be reaching to a 98 or 95, that is actual. So this is, you can solve it out. I guess this will be 80. No, I don't know how much is it, but you solve it. I think 83.7%. Then you have this question, it will be done by your only homework. I'll solve these questions in our practice class. Then we have percentage composition in the compound. Guys, this is very easy actually, believe me. Let us suppose this is a compound CaCO3. What is the molecular formula of this compound? 100 gram per mole. So let's say if you want to ask me what is, how much percentage of calcium is here, so mass of calcium, so this is 40 upon molar mass into 100. This will come up as 40%. So if you want to calculate percentage carbon, so 12 by 100 into 100, 12%. If you want to ask me what is the percentage of oxygen, so oxygen is 48 by 100 into 100, 48%. That's how you get. So this is a question, you just try it as homework. Now I'll take you to one other important term called as empirical formula and molecular formula. And I have seen so many questions in previous years, especially on JEE Mains, these questions have been asked. So I'll explain this part. What is the meaning of empirical formula? Empirical formula is the simplest whole number formula written down over here, and molecular formula is the exact number of atoms which are present in the molecule. So take this example. Guys, we have benzene here, we have ethine here. There are two different compounds, ethine and benzene. This is your molecular formula. The molecular formula of benzene is C6H6 and that of ethine is C2H2. But now if we are talking about the empirical formula, this will become simplest ratio CH. The difference that we see between these two is that if we multiply CH by 6, we will get this molecular formula, and if we multiply CH by 2, we will be getting ethine as formula. So guys, this is very important, that what we are multiplying up with. So you will be getting one important formula as that if we multiply, if we need to find out the molecular mass, if we got to find out the molecular mass, it will be simply some number n multiplied by, and n is nothing number of moles, it is actually any positive integer multiplied by empirical mass or empirical formula mass. And similarly we can say that molecular formula is also equals to n multiplied by empirical formula. So you already know about percentage compositions, you already know about these formula. I'll explain you how questions have been asked previously in our exam. Take one example over here and let us solve everything related to it. So guys, we have been given up with two elements here. It's the simplest possible question, carbon and hydrogen. Just take these percentage compositions of given compound in just grams only. So carbon will be 80 gram, hydrogen becomes 30 gram, not 30, 100 minus 80 will be 20 gram. Try to identify the number of moles. Number of moles will be 80 by 12 and this will be 20 by 1. You take this example and try to find out the lowest possible whole number ratio. Divide everything by 20. This will become 1 by 3 ratio 1. Isn't it? 4 will come 4 by 1 by 3 3. So this will be our 1 ratio 3. So what we have to find out ultimately, nearest whole number ratio. Using approximation we can also do that. Sometimes we also divide by the lowest value to all of them, then we can get the lowest value, nearest integer value, okay, nearest whole number value. Now you do one thing, empirical formula you already got. It will be C1H3. Then empirical mass you will already got to know. 1C means 12 plus 3 into 1 is equals to 15U. 15U is the empirical mass. So molecular formula, okay, first of all you need to find out the value of N. So N is how much? Molecular mass is already given to us 180, I guess, sorry, not 130. So guys, 30U is 1. So you can find out the value of N is equals to molecular mass upon empirical mass. It is actually 2. So 2 multiplied by CH3 will become C2H6. This is how we find out. So that's a calculation that we do for empirical formula and specifically finding out the. So if the two compounds have same empirical formula, then their percentage composition will be different. No. Their molecular weight will be different. True. Their viscosity we can't comment. Their vapor density, no. अरे यार same empirical formula, then they will definitely be having different molecular weight because they will be having different molecular formula. Then one more question is there, you will try it as a homework. We have another question here, try it as a homework. Some question came in JEE Main also, so you people please try this as a question, as a PYQ, and until then allow me some moment, you solve it by your own. Okay, allow me for 5 minutes, I'll be back and join you. Allow me 5 minutes, solve the above question. And those who haven't liked us, please like the session, guys. Hai na? Don't ask me, don't let me ask the same thing again and again. Yeah, guys, hi. So lost one ng has given me submitted with the correct answer. Seems like. So, anyways, we'll discuss this question whenever we'll be having our next session of practicing. So until then, I'm giving you all of these questions as example to you. In my upcoming session, definitely I'll be covering these all questions. Along with these questions, I will bring some very important PYQs also. I'm running out of time. I will directly reach to. So yeah, this is the correct answer, everyone. D is the correct answer in this question. Try using the same method. Last topic of the day, we have concentration. The amount of solute which is dissolved in given amount of solution. So guys, we always need to know that a solution is made up of two components. One of them is called as solute, another one is called as solvent. Solute is usually that substance which is dissolved, and solvent is something which dissolves, right? So now there will be two conditions, everyone. Case 1, if physical state of solute and solvent are are not the same, are not the same. अगर देखिए ये सेम नहीं होगा, so what will happen? Solute will be that component whose physical state is changed while formation of the solution, and solvent will be the one whose physical state remains same. Check it out, guys. Check it one example. We have sugar plus water, and we made sugar syrup out of it. Sugar syrup has a physical state of liquid, water has a physical state of liquid, sugar has a physical state of solid. So going solid to liquid, this physical state is changed. This will be considered as a solute. Since physical state is LL, same, this will be considered as a solvent. That's the first part. We have case number 2, in which if physical states are the same, then solute will be the one which has lesser solute will be the one which has lesser number of moles oblique particles, the one which is having lesser number of particles, and solvent will be the one which is having more number of moles oblique particles. So guys, applying this phenomenon, what we'll do, we'll try to figure out one example. Let us suppose we have 36 gram water plus 46 gram ethanol. So guys, water is H2O, ethanol is C2H5OH. Yes, sure. I'll make a bridge video also. Those who are starting for 11th, I'll make a bridge video. Don't worry. Probably on this Sunday, I'll come up with that video. So 36 gram water, 46 gram of this. So now what will happen? 36 gram of water means number of moles are how many? 36 upon 18. We have 2 moles. Here number of moles will be 46 divided by 46, only the mass. C2 24 plus 6 30 plus 6 16, 1 mole. So which one is higher, everyone? Would you find which one is higher? I guess this is higher. This will become what? Solvent, and this will become what? Solute. Water is solvent and ethanol is solute. So now these are some number of concentration terms that is actually our today's target, and we'll try to finish all of them, and I'll give a quick review of these. Like most importantly, we'll do these will be covered later, not formality, only normality will be covered in redox reactions after equivalent concept. After the concept of equivalence. Okay, these all we need to complete right now only. So I'll go a bit fast. Mass percentage composition. Percentage means out of 100 we are talking about. If you have to find out percentage by mass, guys, this formula is pretty easy. Percentage W by W is equals to mass of solute divided by complete mass of solution, which can also be taken as mass of solute plus mass of solvent multiplied by 100. And it's a unitless quantity. There is no unit in that. Then we have percentage mass by volume. Sorry, percentage volume by volume. So V by V will be equals to volume of solute upon volume of solution whole into 100, and again it will become a unitless quantity. Then we have percentage mass by volume, also called as percentage strength of solution. How is it calculated? Percentage W by V, mass of solute that we have to take into grams, volume of whole solution that we need to take into ml into 100. No doubt unit will be something, because above the numerator is gram, the denominator is volume. So gram ml inverse. Percentage gram per ml is the unit. Percentage gram per ml is the unit. One question is here, everyone, for all of you who are watching this lecture and want to solve some good questions on concentration part. So what would be the mass by volume percentage? So we got to find out percentage W by V, in which 20% mass by mass. So we have been given what? Percentage W by W, 20%. I think these are very easy questions, but we only need to take a good direction how we have to start up with this question. We need a good direction only. So guys, always remember that you can assume whatever be the amount of solution, the concentration remains constant. Concentration doesn't change. Take an example of density of water. Whether you take 1 spoon of water, 1 cup of water, 1 bottle of water, 1 bucket of water, everywhere you will find that the density of water is 1 gram per cc. And in exactly the similar way, concentration doesn't change with the amount of solution. So take this example that if W by W is given, let's say solution be 100 gram. So guys, if solution is 100 gram, then 20% of this will be solute. So W of solute will come up as how much? 20%. That 20% of this. So 20 by 100 into mass of solution is equals to 20 grams. So 20 gram is this, solution is this. We also need volume of solution. So guys, you all know that density is equals to mass per unit volume. So mass, let me take it into gram, like a given mass W by V. So volume of solution comes up as, mass of solution is 100, density is 1.02. So this is gram and this is gram per ml. Gram will be cancelled. Your answer will be 100 upon 1.02 ml. Now do one thing. So you need to find out percentage W by V, and everything is reverse. So mass of solute is 20 gram. Volume of solution is already known. 100 upon 1.02 will go above, and this is in ml. So into 100. 100 cancel out. I think 20.4 percentage gram per ml is the correct answer. Check it out, guys. Check it out. Correct answer A. So that's how percentage composition is done. Okay. Then we have mass fraction, the another important term, mass fraction. Guys, do you know the meaning of fraction? Fraction means out of 1. Just like percentage means out of 100, fraction means out of 1. So mass fraction will become equals to, let's say, mass of solute upon mass of solution. It's that simple. This is the you can also do one thing, that mass fraction is also equals to percentage W by W for solute divided by 100. Because percentage we were identifying out of 100. If we have to identify it out of 1, then you just need to divide it by 100, you will get your answer. Again, it's a unitless quantity. Next is mole fraction. So guys, mole fraction is actually the ratio of the individual number of moles to the total number of moles. Total present, like total moles of all the components inside a solution. And mathematically it is represented as, I'll tell you how. See, so let us suppose we have only solute plus solvent with us. So guys, mole fraction of solute can be written as number of moles of solute upon total, means add all the moles of all the components present inside the solution. Similarly, now x of x, this is not x actually, this is the Greek letter called as chi. So chi for solvent will become what? Number of moles of solvent divided by solute plus solvent. So if you add both of them, x of solute plus x of solvent, you will be getting 1. So if you have known about one of the component of x of solute, then another will be 1 minus x of solute. X solvent will be equals to 1 minus x solute. Let us suppose there is a solution containing more than one kind of solutes in it. So solvent will be one only. So let us suppose this is A, B, C, D, E. So many things are there. So guys, any individual mole fraction of, let's say, I you want to calculate out, will be equals to number of moles of I divided by Na plus Nb plus Nc Nn and whatever are there. That is how we do. So now apply this formula in this question and clarify your doubt related to this part. So calculate the mole fraction of acetone. So guys, tell acetone, mole fraction of acetone will be equals to number of moles of acetone first. So number of moles of acetone are how many? 7 moles. And how many total moles? 1 plus 2 plus 7. So this is 7 by 10. C. Chalo. Now we have next term called as parts per million, ppm. Guys, parts per million and parts per billion are two terms. So like out of 100 it was percentage, out of 1 it is fraction. Million means we are taking out of 10 lakh. Million is actually 10 lakh. So actually it is equals to 10 to the power 6. So out of 10 to the power 6, that means if something is in very lesser quantity, that will be expressed in terms of ppm and ppb. So the formula of ppm is very simple, everyone. This is ppm is equals to the mass of solute upon the mass of solution complete into 10 to the power 6. Similarly, parts per billion will be equals to mass of solute, mass of solution into 10 to the power 9, because billion is equals to 100 cr. Wow, yeah. 10 to the power 9. Now try this question. This question is for us. We have been given up with some seawater contains 5.8 10 to the power minus 3 gram dissolved oxygen per kilogram. Concentration in parts per million. So guys, ppm will be equals to what? Mass of solute 5.8 10 to the power minus 3 gram. So this should also be 1 kg is equals to 1000 grams into 10 to the power 6. You can solve it, you will simply get 5.8 ppm. Now we have another concentration term called as molarity, and I guess this is the most important term that is gonna to be very much repeated throughout this year. In 11th standard, so many chapters will come where you will be using this term molarity. So let us learn about it. Molarity is actually defined as the, so guys, I'll give you the best simplest definition. You have 1 liter solution of anything. Let's suppose you are making 1 liter rasna or 1 liter any kind of milkshake you are making. A milkshake is not a good example of solution because we have to talk about true solutions. Milkshake is a colloidal solution. Colloids are heterogeneous. Come to the homogeneous part. We have molarity, we have 1 liter solution of anything. Let us suppose sugar is dissolved in water and the solution is made up to 1 liter. Now out of this 1 liter, how many moles of sugar are we dissolving? This is called as molarity, number of moles per unit volume. So guys, the formula becomes what? The formula of molarity becomes what? That number of moles of solute divided by volume of solution in liters. So now you can check out, if you are dividing with volume of solution in liter, this will become what? In 1 liter, how many moles of solute are dissolved? This is molarity. So this can also be written down as, we all know that generally number of moles of solute can be defined, but volume of solution might not be given in liter, it might be given in milliliter. So guys, need to convert it, dividing by 1000, and 1000 goes up, and this becomes what? Number of moles of solute into 1000 divided by volume of solution in milliliter. That is one of the formula. This can be another formula. If we are writing or we are fully expanding the number of moles into given mass upon molar mass, then it will become W solute upon molar mass of solute into 1000 divided by volume of solution in milliliter. So guys, that's a formula that we have. Using this formula, we can also find out the units. So guys, units are pretty simple. We have numerator as mole, we have denominator as liter, mole per liter, or mole per liter, or we also said capital M stands for molar. Molar could be centimolar, decimolar, millimolar. So let us suppose there somewhere it is written, let M by 10, M by 100, M by 1000, somewhere it is written like this. So guys, M by 10 means decimolar, that is 10 to the power minus 1 mole liter inverse. If we have been given up with M by 100, it will become centimolar. Centimolar means 10 to the power minus 2 mole liter inverse. And if we have millimolar, millimolar means 10 to the power minus 3 mole liter inverse. That is. We have a question here on molarity, that a solution of NaOH was prepared by dissolving 1.6 gram NaOH in 500 cc means ml, okay, cubic centimeter means milliliter only, and calculate the molarity. So we can directly apply the formula of molarity by given mass upon molar mass. Given mass is 1.6, molar mass is 40 into 1000 divided by volume of solution in ml 500. Use this data 2, this data is 20, so 16 by 20 into 10 to the power minus 1, this is, I guess the answer will be 0.08 mole liter inverse. So guys, that is about molarity, and you all are right now pretty much comfortable solving molarity. Now we have the last topic, molality. And guys, after in the practice session only, I'll explain a bit more in detail about molarity and molality. But right now we'll basically wind up the session, and I would expect, because it's plenty of things that we have covered for the day, and I want you people to practice it more and more. I have plenty of questions in my this theory lecture, so you try it by your own, and then we'll be coming on my practice session next week, exactly on Friday. Then I will cover not just the topic, and I will cover all the problems. We'll practice, we'll also try solving the concepts related to molarity, their interdependence, and some of the more law of dilution, law of mixing, like that. But today we'll cover up to molality. I think that will be enough for the day. We have covered already a lot of things that we had to. We have molality. Molality means right now what we are doing is we are trying to mix sugar into water, and the entire solution right now weighs 1 kg. So in this 1 kg solution, how many moles of sugar was dissolved? This is called as molality. See how easy is this to define. So guys, formula becomes molality is represented as small m, and that is equals to given mass upon, not given mass here, number of moles of solute dissolved in per gram of solvent. Okay. That was not the mass of solution, that's a mass of solvent only. So upon W of solvent, and this part has to be taken in kg. This is the number of moles. So small m will become equals to number of moles of solute divided by, we all know that mass of solvent can sometimes be taken into grams. For that we have to divide it by 1000. This denominator goes to numerator. This becomes m is equals to number of moles of solute into 1000 divided by mass of solvent, and now this mass of solvent is in grams. Also, we can expand this whole formula by writing W of solute upon m of solute into 1000 by mass of solvent, and that too in gram. So that is what the final expression, a more expanded formula is. Now, if you talk about the unit, we have a very simplest unit, that is mole upon kg. So moles are numerator, denominator is kg, mole per kg is 1, or you can write as mole kg inverse. Or there is one more unit, small m, stands for molal. So molal, earlier we stand in the terms of molarity we said molar. Now here we are using molal. So the meaning of molal is, sometimes it can be written into m by 10, m by 100, m by 1000. This is called as decimolal, equals to 10 to the power minus 1 mole kg inverse. It could be centimolal, is equals to 10 to the power minus 2 mole kg inverse, and it can also be millimolal, that is 10 to the power minus 3 mole kg inverse. So that is what the about unit of this concentration term. And apart from the unit, we have some simple questions with us. Now let us try some questions. Guys, here is a question that 7.45 gram of potassium chloride was dissolved in 100 gram of water. Then calculate the molality and molality of the solution. So we'll apply the same formula, that small m is equals to given mass upon molar mass. So now let us first find out the molar mass. We have KCl with us. Capital M has to find out. Mass of potassium is 39. Mass of chlorine is 35.5. This whole becomes 74.5 gram per mole. So now what we'll do? 74.5 into 1000 divided by mass of solvent which is 100 gram. Just try solving it. I guess this is very easy. This is 1 mole kg inverse. 3 is the correct answer. So this is, you will do this question. Some of the homeworks are given, everyone. You try it by your own, and I will explain you the relationship between molarity and molality. So let us suppose sometimes you have been given up the molarity, then how can you convert it into molality? So we have to assume something. We already know that we can assume whatever the quantity of solution we want to assume. So let's assume, let's assume the molarity of solution be capital M, and the unit will be the same, mole liter inverse, right? So guys, what you'll do, what does it mean? Means capital M moles of solute are dissolved in 1000 ml or 1 liter solution. So guys, if we know density of solution, then we can know the mass of solution. So W of solution can be find out as 1000, or like simply volume into density. So volume is 1000 ml into density, and this will come up into grams. So let's say D is in D gram per ml, and 1000 gram was already there. So ml was there. 1000 ml multiplied by this will give you the value of mass of solution. Now you already know the mass of solvent will become mass of solution minus mass of solute. Solution we already know it is 1000 D, but we do not know the mass of solute, but we know the number of moles of solute. So we can use this data, number of moles of solute. Number of moles of solute is how much? Capital M into molar mass will be written down as M solute. So M multiplied by M solute is the mass in grams for solute. So that is how you get the value in terms of gram only. This is your mass of solvent. Now everything is pretty much given to us. Simply apply the formula of molality. Molality small m will be equals to moles of solute is capital M, which is equals to molarity upon mass of solvent. Mass of solvent 1000 D minus M into M solute, and whole multiplied by 1000, isn't it? So guys, this is where you will get your answer. Till here you will be getting your answer. You don't need to do so much of hard work. But yes, if you wanna reach to even easier method, you can just reciprocate it, and you can get one more formula. This is one formula, or 1 by m is equals to, see, this is 1000 m, so 1000 will be cancelled out. I guess this will be D by capital M minus this will be M into M solute upon 1000. So this will become simply M solute by 1000. That is one of the another formula. But guys, I personally recommend all the students, sure, VIEEE, I'll make one video. Okay, thank you SP. So guys, what I'm explaining right now is that whenever we calculate the formula and V1 by M equals to D by M minus M solute by 1000, this might be very easy to remember. But if you solve the questions, and you will face so many problems using this formula, because whatever the answer you will get, that answer will be in reciprocal. Then you will reciprocate that, and specifically these answers will be in this way, like 1 by, like let's say 0.345, and then reciprocated stuff. So I must advise you that you always use the derivation every time. Use derivation and get the answer. So I'll explain one question to you. Upon the same question, I'll explain one question. Same concept. The density of 1 molar solution of NaCl, and this something is given. So guys, simply do one thing. This is 1 molar. So 1000 ml multiplied by density is 1.0585 gram per ml will give you the 1058.5 grams. This is equals to mass of solution. So mass of solute will be how much? Number of moles into molar mass. How many number of moles have been given to us? 1 into 58.5 for NaCl. Then it will give you 58.5 grams only. Using these two data, what we can find out is mass of solvent. Solvent will be how much, sir? 1000 58.5 minus 58.5. Value will be 1000. Now easily small m can be calculated as number of moles, which are 1 molar upon 1000 into 1000. I think the correct answer should be 1 molar only. 1 mole lul, 1 mole kg inverse. So there are plenty of questions that you can try by your own, everyone, and we do not have too much of things left from here, and some of the good JEE Main problems are here, and law of dilution and law of mixing are two things that I'll explain in my next class. And right after that, we have plenty of questions here for your practice. So guys, keep practicing, keep motivating yourself, and we'll connect in our next class only. Now is the time I think we should take a leave. Do connect with me in our next class. That's it for the day.